We got a few stragglers. I'm gonna let them find their seats. Everybody have a good time last night? Yeah? Wow. Thank you for starting it, and thank you for actually making something out of it. How were the chickens? Chicken. Yeah. I saw a random wild foal wandering around. Awesome. Again, welcome to day 2. Thank you for everybody for coming out relatively early. Did you grab coffee already? 7. Yeah, 7. Okay, beautiful. Just a reminder again, I want to thank everybody for wearing your masks, being mindful of that. Really appreciate it. I've heard really good things from the staff. They mentioned that this is the best compliance they've ever seen. That's kind of a sad compliment in this day and age, but thank you regardless. I really do appreciate it on a personal and professional level. Reminder, no food or drinks in the theater, except for the exceptions I think that they have on their website. Reminder that we have the rehearsal hall on the 3rd floor if you just want a little bit more space and want to watch the live stream up there. And just one last note, we have all of our sponsor parties tonight. If you're looking for specific details, where to go, what time to be there, check out the Tuesday Night Lights channel. There's a pinned message with actually a map. So if you want to do your own crawl, you can do a crawl. So I think that's it. We've got another exciting day full of talks. Quick little background in case you haven't been here before, which again, I think based on yesterday's response suggests that there's a lot of first timers here. The way I generally try to do this event is it's kind of an arc where the first day is kind of higher level, more aspirational type talks, kind of get you thinking. And then as we go, we get increasingly more technical. So the feedback I got yesterday was that everybody seemed to really enjoy the talks. They weren't too high level, too abstract. So that actually is a fantastic signal. I think I'm really excited for today's talk, which tends to be more heavy on the practitioner's aspect and perspective. So with that said, I'm going to kick the day off with our first speaker, Chris Ward of Chronosphere. Big round of applause, please.
Actually, I'm pleasantly surprised to see so many of you here for the first talk after a party. Thank you very much. So, about a month ago, I think I've lost track of time a little bit, I was at KubeCon EU in Valencia, and wandering the exhibition halls and looking at the schedule of talks, it really amazed me that projects like Kubernetes have now become such an essential part of many application stacks. It's actually quite hard to imagine building anything without it. And I've reached the end of this slide, and this list of sponsors from KubeCon EU is still going, which shows you how many booths and various vendors there were. And there we go, it's still going. You get the idea, there's a lot out there. It's a lot of applications and vendors trying to help us with that. I think this image is probably familiar to many of you, the infamous CNCF landscape image. It kind of struck me as well that fairly quickly that some projects such as Kubernetes, and you can add to this list many common programming languages and other things we use very regularly, have become so complicated that we need to add dozens of other tools and dependencies to use them efficiently and effectively. And this is the CNCF landscape picture. I had to zoom out 80% to fit it on the screen. And now there's even a special interest group, a SIG at the CNCF, to help people navigate this. That's how complicated it's become. There has been a long era of relatively affordable cloud computing resources, and this increased the temptation for us to keep throwing more cloud-based resources at problems, as there was a relatively minimal impact on cost, and we gained a lot of advantage and flexibility from doing that. We didn't want to repeatedly write boilerplate code, so we used frameworks and other dependencies to hopefully focus on what was really important. We needed tools to help us handle demand, tests, build applications, orchestrate applications, create infrastructure, manage infrastructure, etc., 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 etc. To a point where we kind of started to lose direct insights into our technical stacks and what was happening inside of them. So we added more and more tools to help us understand what we had lost sight of. This is, of course, where observability comes in, but also efforts around security, another active project inside the CNCF at the moment, and a big topic at KubeCon was about bringing security insights to these applications. Things like the software bill of materials, rather comically abridged to S-bombs, which maybe kept laughing, thinking people were swearing, but that's a whole other conversation. And now, for various reasons, we find ourselves in a moment where we're actually starting to question the financial impact to businesses of this growth and reliance of all these cloud services. And there are now more tools to help us monitor and streamline the costs of those. Even things like Terraform now have some open source projects and some commercial projects that give you an indicative cost of what rolling that out might be. There's even now an entire sub-foundation of the Linux Foundation called the FinOps Foundation, which aims to help increase skills and awareness and techniques and practices around efficient cloud usage. But there's another unintended side effect of this cloud proliferation of services and frameworks and this kind of throw another service at it development. And that's what I'd like to talk about today, and that's an impact to the environment, to the world around us. It's quite easy to forget sometimes with all this abstraction that behind all this code, all the pushes we make, all the tools we use, the builds, the applications and processes is actually real hardware running in physical locations somewhere. Why am I here and talking about this topic? My name is Chris Ward. I go under an online nickname of Christian Chiller a lot because my real name is so common, it's impossible to find me. So I use a nickname so you can actually find me. I'm the technical writer at Chronosphere. You can see my Twitter handle here and also the Slack channel if you want to ask any questions. I work on the documentation there, a lot of the tech blogs, and also host a new video series we started. I'm fairly new to observability. Chronosphere offers its own kind of take on observability tooling. But why did I want to talk about this topic with all that in mind? Well, actually, it was after a conversation with someone from the FinOps Foundation at KubeCon. And I've always had a bit of an interest in helping developers and encouraging the development ecosystem to think differently about what we do. And I used to actually work in Australia in technology for environmental organizations, mostly in jobs that were then called webmaster. So there's always been a bit of a thread of interest in the topic. And then this conversation with Ben here really sparked something in my mind, even to the point that I asked Jason, the organizers here, if I could change my talk about a month ago. and thanks to them for letting me do that. And I hope that my kind of naivety and enthusiasm on the topic doesn't show too much and you find it interesting. So how big is the problem? A lot of this at the moment is hard to get exact numbers. We have to do a lot of back-of-the-envelope conjecture and kind of manipulation a little bit to get some numbers that are useful to work with. And there's a few sources I will list as I go. So bear with me. There's a little bit of extrapolation you have to do here. So according to, actually there was a BBC article which then references other reports, and this is mostly taken from a couple of sources to get to around 3 to 3.7% of carbon emissions. This is actually almost the same as the airline industry, which people pay a lot more attention to in this scope, but actually is probably harder for them to change that in some respects than for us. And data centers on their own account for about 1% of emissions, so actually a fairly high percentage of that. But of course, internet usage, and I will question what that means in a second, is increasing rapidly. There's now about 50% of the global population using the internet, and that's obviously growing very, very quickly. And I kind of think when these surveys refer to the internet, it's a little vague. What does that really mean when we consider the wider usage of the technology we create? So I would probably say this number is a lot higher, especially if we consider a lot of that indirect infrastructure that a lot of us work on that people use on a day-to-day basis by billions of people. So if you attended Adrian Cockcroft's talk yesterday afternoon, we did talk before this event and kind of figure out how we could overlap on some similar topics. He mentioned to me this cloud carbon footprint project as a good tool I could use to illustrate some of my thoughts and here for this talk. It helps you look at the carbon impact of the sort of three main cloud providers, AWS, GCP, and Azure, but it is open source. It's mostly looked after by ThoughtWorks, so you can make contributions to add other sources, I guess. And as a bit of a recurring theme here, it's actually a reasonably complex application in itself, and of course has its own overhead, which is worth bearing in mind, but I think in this topic, sometimes you just have to start somewhere, which is kind of why it's useful. How does it calculate to calculations? I don't want to go too much into this number. You can find a lot more detail on their website, the cloudcarbonfootprint.org. But this is roughly how it calculates some of the numbers I will show. Okay, I'm going to be bold and attempt to do a very quick demo. Yeah. So this is it running locally on my machine with mock data. Just to give a quick idea of what it looks like when you start it. It's a node application. You can see the different cloud providers. You can see the accounts on those providers. You can see the various services. You have a date. And on this chart, which we're kind of used to, we have emissions over time, each day with metric tons, kilowatt hours, and cost. It then gives you like a rough estimation of what that kind of means to figure that out. We have breakdowns here by region, service, and account. I find the service one kind of most interesting. And then actually another interesting part is this intensity map. So by each provider, which data centers are the best or worst to be using. And this is actually one of the other areas I find quite interesting. So this was kind of helpful, but I wanted to try and measure something myself. So I built a demo application. It's a little hard to build a very effective demo for this because often you need to track it over time to get a long time to get a good idea. And also, I'm not really an engineer, so building a very complicated application is not my forte. So I went for something quite simple, and then I made a lot of estimates about how I would increase the numbers I got out of that to get something more realistic. So I just made a node application that I then measured at various stages. I kind of made some assumptions that there would be an average of 1,000 concurrent users over a year to get to my final numbers. I ran it primarily in EU data centers, mostly just because that's where I live. I used GCP because I understand it the most. The application that I made used Cloud Run, Cloud SQL, and here's where things get interesting, then all the other services that were necessary to support those. So this included, I'm going to actually find the list, Bigtable, the artifact registry, logging, and billing. All these services that are not actually central to what I'm doing, but are still running. This kind of gives you the theme of the talk here. So here's what I ended up with. Ignore the values, because as I said, this was running kind of low payloads, but mostly I'm interested in looking at the scaling here. So right at the bottom is where I literally just ran node, JavaScript, console.log, hello world. Pretty minimal impact, still something, but fairly minimal. Then as it ramps up, I added Express, the sort of infamous JavaScript REST API framework. And then again, just with an API endpoint, console.log, hello world. It adds about 57 packages. Obviously, JavaScript is somewhat infamous for this. And it jumps up quite a bit. Then, when we get to the top, is where I changed things a bit and added a SQL database. And instead, I loaded just 3 rows from a database table and displayed those instead. And it jumps up quite a bit here. The next one is where it surprised me. I added a just wasting time function that did a lot of kind of unnecessary mathematical processing just to kind of simulate a heavy workload. And it actually didn't make a lot of difference, which sort of surprised me. Maybe it doesn't surprise others, but it surprised me. And then the other interesting thing is I then left it for a few days, And it doesn't drop down to 0, which is weird, and I don't really know why, but that surprised me as well. I don't know what was going on there. Something kind of running in a background, I guess, that I'd forgotten about. The services may or may not surprise you, but it surprised me. By far, the biggest consumer and impact to carbon emissions here was Cloud SQL. Probably isn't surprising. I actually used to work in content management systems and remembered that you always had to put caching and all sorts of optimization in front of SQL databases. But considering it was doing so little, it's actually kind of surprised me. But maybe I shouldn't be surprised. So, what does all this mean? So again, I took all those numbers to get kind of a more real-world number, and this is what my little application running over a year would have an impact of. So about one-way flight from London to New York City, about 140,000 phone charges, and then to sequester all that carbon, about 20 seedlings grown for 10 years. These numbers don't effectively really seem that high, but bear in mind this was a very simple application. Multiply those kind of numbers by real-world applications running, hundreds of thousands, hundreds of millions of applications running all around the world all the time, and you start to see where these numbers increase quite rapidly. And so what? I've never been one that liked to just give a talk that told the audience about a bunch of problems they had to worry about, but didn't really give any advice about what you could do about it. So here's a few ideas. Now, obviously the most obvious thing to do is streamline services, make more efficient services. This is Monitorama, this is an observability conference, the perfect place to learn about that, of course. In fact, you're probably already doing it, or you know how to do it, or you want to learn how to do it, and many of the tools in this ecosystem will help with that, and then indirectly with environmental impact. So an inefficient service is quite often the source of that biggest impact, and one of the easiest targets for us to target, and have other benefits as well, of course. So in addition to that, obviously some other things we can think about are using compiled code or compiled languages. I used a very unoptimized JavaScript. There's obviously much better ways to build some services than that. Thinking about things like dependency updates, of course, that might fix memory leaks or make things more efficient. Or more interestingly, actually providing features if you're kind of a provider that help your customers. So an interesting one at Chronosphere is we have a feature or several features that let customers optimize the metrics they're storing with us. So this helps everybody in a bunch of different ways, but indirectly, because we're reducing impact on our cloud hosting, it also reduces that environmental impact for us and customers as well. So, there's sometimes you can offer features that think about these things as well. Thinking a little bit broader, there's some other aspects we can also look at. Being selective with providers. Certain providers are better than others. And then if you think back to that map we looked at, greener data centers. This uses this term PUE, power usage efficiency. And if you saw Adrian's talk, I think he covered that it's not a perfect calculation, but again, it's kind of one of the better ones we have at the moment. But also in terms of location, not just greener data centers, but location to your users. If you have a user in Europe and you send all their data to America, obviously there's other reasons that's not a good thing to do, but that transmission also has an impact. I actually found entries of this in the dashboard of transmission costs. So this ties very nicely into CDNs, of course. These are a very kind of quick win to reduce some overall impact as well, and again, other benefits, of course. I was pleasantly surprised to see that pretty much all of those three providers provide their own sustainability tools. They require running applications over a long period of time, so I couldn't really use them. And of course, I would think a lot of people are using hybrid clouds anyway, so the other project helps us aggregate across a bunch of different sources, but they also do have them. And I'm starting to wonder if there might become something very soon where customers might start asking for impact reports, whether this is because they want to or because certain regions in the world start demanding them. It's actually something to start thinking about. So if we can already start thinking about them and working towards that, we're getting ahead there. Don't forget the front end. This might be a strange thing to mention at an observability conference, but the front end is, of course, a fundamental part of many applications and probably already part of your observability stack. But the front end is a special case because it doesn't just affect you as a provider. It also affects your end users because they're accessing a version of your application. So take all those impacts we mentioned earlier and multiply them by quite a large amount, and it's having a much bigger impact on things. We all know and joke about how browsers use up so many resources on machines, and that means something, of course. That's electricity. But fortunately, the front-end community has actually been thinking about this for some time and is a little bit ahead, actually, in regards to other parts of application development. And here's a few useful links. The CSS Tricks blog was actually one of the first things I read a few months ago that made me slowly start thinking about this. And they have a whole series on optimizing front end for reducing impact. And of course, that indirectly is an environmental impact as well. There's also the website Carbon Project. I found several books on the subject, and this Tom Greenwood's, I think, was from A List Apart, which is always a very good source of information for web design, especially. And then sustainablewebdesign.org, another really good list of resources I found. Purely by absolute coincidence, Google even has an event on this subject today. So hopefully if I ever run this talk again, I will watch these videos and bake some of that in. It's kind of a shame that it wasn't yesterday and I couldn't have watched them. So I guess my summary here is reiterating my last point, that I get a feeling that this might become something that we have to do in the near future. So you can get ahead of that requirement and start thinking about the impact of applications as well. And observability already provides us many of the tools we need to get this information, so we could start building things like dashboards, etc., to start monitoring this now. So if it's not too much of an extra step, why not try, I guess, is my summary. Thank you very much. You can find my personal information here, and if you want to know more about Chronosphere, here's a QR code, or if you don't like scanning random QR codes on a screen, there's a random link instead. And we have t-shirts, there's a PlayStation giveaway, and a bunch of other things as well. So I'll always be happy to talk to you. And thank you very much, and I'd be interested in hearing questions, or at least discussions. I don't know if this is a topic that has concrete answers yet. So.
Yeah, are there any questions? Ooh, man, this is clearly Jason was standing here. Any questions?
Up here.
Oh, there we go. See ya.
So your talk and Adrian's talk yesterday, there was a lot of estimates. What level of confidence do we have around this information? Are we just mostly guessing? Are we off by a magnitude of 1, 2? Where are we in terms of accuracy of understanding the impact?
And then just repeat the question.
Yep. So the question was, how confident are various people interested in this topic about the numbers we have being helpful? I think, especially bearing in mind some of my experience in this sector in the past, is as well that everyone has a different measurement as well. So getting a consistent opinion is also quite difficult. It's not an exact science. It's a problem we know we have, but how we get to knowing we have the problem depends who you speak to. So I think we can be confident in knowing that there is a meaning to those numbers, and high is generally bad, but whether they are completely accurate, I think, will really vary, and there's going to be a lot of different opinions on which values we should use. But I guess I would hope that the general consensus becomes that it doesn't, if you want to care about this topic and move on, using any kind of value is useful, and as long as you trust it and you have the evidence you've read to believe that it's useful, I guess that's enough for you. But I would also assume that if this does become regulated, there will be numbers then that we have to measure more strictly, and whether we like them or not, those will be what we have to follow. And I think this comes up a lot in tech, get ahead of the regulation so you can actually influence something more useful than what governments might come up with. And I think Adrian probably went into a lot more detail about some of the problems with some of the calculations as well, and how we can fix some of those. So that's kind of my answer. Oh, I saw the guy in blue first.
If you're trying to compare your own in-house software to vendors' software, have you thought about how you would kind of benchmark different software offerings for comparison? Is there anything in any of this universe that is a benchmark that you can use?
So the question was, are there any benchmarks you can use at the moment to compare different vendors? I'm not completely sure of the answer to that question, especially bearing in mind that a lot of vendors may not supply anything, so there's nothing to benchmark. If you're running it yourself, which can happen, then you can get your own benchmarks, of course. You could also, if you're in a demo stage, for example, with vendors, you could request it and thus give you, if you're a valuable account, they might give you those benchmarks you can then compare. I think you can possibly get other indications as well, leading into that efficiency, that if the application is memory intensive and slow, etc., it's probably having other impacts, and if another equivalent isn't, then it's probably having less of an impact. That is, of course, a little bit of conjecture, but that's probably, if you have nothing, you can kind of get a rough idea. We all know there are certain applications we run that really hit a computer. This is obviously on a local level, and those that don't, and we often tend to prefer the ones that don't. So we can kind of do some very rough benchmarking there. But I reckon actually probably the answer I would like to give is start asking for those benchmarks, and then you have them. But that might be a challenge to begin with, but maybe in the future. Yeah.
Oh yeah, we're good.
So in your research in the front end stuff, is there anyone working, so like there's new carbon data sources now about generation that are real time, so like what, for a particular location, what's the carbon mix at that moment for maybe hour periods that are being used pretty frequently now for tracking this at the cloud level? Is anyone doing it at that granularity with their front end assets, like using that data and user reported locations to kind of figure out what offsets things are by?
So the question was, are there any real-time kind of dashboards or monitoring for the impact, especially on the front end? Yeah, was that? Yeah. Again, I'm not 100% sure, but the interesting thing I found with my research on the demo applications I made is a lot of them currently work off billing data, which is often delayed.
Right.
So
New systems are coming on
yeah.
right now.
The front end would probably mean you'd still have to know, there's that, in the calculation, there's the embodied emissions, which is the stuff that's harder to know about because you don't always have direct access to it at that moment. But you could probably, take that, extrapolate it, and then build that into the more instant feedback you can get in modern web applications. But I don't know of anything that does exist, but it might. I would actually envisage it possibly does. I just haven't found it because the front-end community moves fairly quickly. So it probably does exist, and I would like to go and find it. So thanks for giving me that to look into.
Cool. Any other questions out there? Awesome. Great. Thank you so much. This is awesome.
Thank you for having me.
One round of applause. So while our next speaker is getting set up, how many people went to Castaway last night? Did anyone get the story of what was up with that chicken that was walking around? Was that a pet chicken?
It was from next door.
It was from next door. Like, it just wandered over, or?
They apparently have a bunch of chickens next
Oh, they just have a bunch of chickens. Okay. Yeah, all right. Felt like that's very Portland. It was very odd from my perspective because I just gone to dinner at the chicken place that's being mentioned in the Slack channel. And so then showing up and then see this chicken around. It looked pretty aggressive though. Like it got a little too close as people were eating. It was kind of felt like it was just like staring at you, like give me your food. Awesome. Which one of the speakers is streaming Netflix right now? God, they're hot corners.
It's on the right.
Okay, here we go. We're gonna turn it off and turn it on again. Now, there we go. Okay.
All right.
Is this on the right one?
It's on the right.
I'm gonna let you try.
All right, let me get this.
There's a certain level of crazy when you have like all of the hot corners set up to just move all your windows around at like completely random. And then everything moves.
Okay.
Yeah, there you go.
There we go.
Yes, we can do it. All right, let's give a big round of applause for Fred Moyer.
Alrighty. So, hey folks, welcome to my talk about SLOs, SLIs, and air budgets at scales. I first proposed this talk close to 2 years ago, and Jason was gracious enough to keep it on the schedule, even though throughout the past couple of years, we've had a new normal. Over that time, I've given variations of this talk in different online conferences, and I've learned a lot on the subject matter during that time. So I'm really pleased to be presenting the sum of my learnings over the past couple of years. This is kind of the greatest hits version of the previous talks that I've given on the subject. But first, I've got a little survey for folks. Raise your hand if you know what this graph is. Pete, is your hand up? Adrian, folks? Okay, if you know, you know. Raise your hand if you've used this in anger. All right, we've got some folks. So we all know we're here today in part because of this thing. If you don't know, that's okay, but we're gonna come back to this. So hi, I'm Fred. I'm an observability engineer at Zendesk. Our COVID travel policy is still a little bit weird, so I'm here on my own to present this, which means that the opinions in this talk are my own, not my employer's. I've been working in monitoring the observability space for about as long as the graph on the previous slide. And I like to think about SLOs, air budgets, histogram, and I've got 2 young kids, so I'm definitely happy to get some of this great Portland coffee. Let's kick it off. So about 3 years ago, I took a new job at Zendesk, and because I've been focused on this relatively new thing called SLOs, I got tasked with a project to bring SLOs to an engineering organization with over 1,000 engineers. At the time, there was a big push to make the product as reliable as possible, so I needed to come up with a way to roll out SLOs and air budgets. And to do that, I really had to understand what SLOs and SLIs were programmatically, so I did some research. I started off with reading the basics, the SRE book, the SRE workbook. I know folks have seen Liz Fong Jones and Seth Vargo's Google Cloud presentation on SLOs. Great video. I'd given a number of SLO-related talks previously at a previous job, and one that you may have seen was called Latency SLOs Done Right, which was also presented by Theo Schlossnagle and Heinrich Hartmann. But even when I look back at that talk and watch it, I can spot the errors that I made in it. Subtle errors in the formulas and error here and there in the math. And what I really found researching this topic, that there wasn't a prescriptive equation for SLIs and SLOs as a formula. The Google books talked about SLIs, but were kind of vague on the subject. I mean, they had some formulas here and there, but they weren't that consistent. They had formulas for SLO, but when I dove into the details and tried to match them up, some of the times they had a time period, other times they didn't, so they were more abstract concepts. And a recent book, Implementing Service Level Objectives by Alex Hidalgo, actually had a phrase in there saying like, I'm not deliberately not being prescriptive, because each of these are going to vary depending on what your organization's needs are. So out of all these resources, I found Liz and Seth's video. They had some strongly prescriptive formulas in there, and so I took those and I started to use those as a base for what I was going to implement at Zendesk. And over the next few years, 2019 to even 2016 to 2022, I call it a Cambrian explosion. Haha. There was just a ton of material coming out. There's SLO Conf. Alex's book came out, lots of conference material. And so as I moved along through the process, I implemented a lot of those resources. So I got to work on making formulas that would work across a large engineering org, and I didn't want a lot of room for creativity or variance, because in essence, these are math formulas. And for folks who've worked at large engineering organizations, they know that the whole entire organization doesn't always do things the same way. So, formulas for SLIs. This is what I came up with. I've got a few examples here. An SLI is basically a way to delineate good requests from bad requests. A couple examples. My 99th percentile homepage latency over 5 minutes would be less than 500 milliseconds. My homepage request could be served in less than 100 milliseconds. My homepage response code is not a fail whale. And each of these had common components that I parsed out. There's a metric identifier, a metric operator, and a metric value. And these are examples that humans can parse easily in their head, and that conveniently you can also implement in any one of the open source or commercial solutions for monitoring or observability. So I went with these as a starting point for SLIs, and they also mapped pretty well to Liz and Seth's video. An SLO. An SLO is the number of good requests divided by the number of bad requests over a time range. So these also, I used color coding to parse these out so folks could understand them. We have 3 components. A success objective, which folks know is 99% usually. We have your SLI, which is embedded in the middle of the SLO. And we have a time period. A few examples here. 99.95% of 99th percentile homepage latency over 5 minutes is less than 500 milliseconds over the trailing month. It's a little bit of a mouthful on that one. Similarly, you can do the same approach with response codes or individual homepage, individual service requests. I tend to favor the latter approach, measuring individual requests as events rather than taking aggregates over time range, and I'll go into why on that a little bit later. And then how do you get an error budget from an SLO? Well, you just subtract the SLO from 1, subtract the success objective. So in this case, if I'm going for 99.95%, my error budget will be 0.05% of requests. And in this case, when I have 0.05% of requests that have not met that criteria, my error budget is considered exhausted, which is also known as an SLO breach. So same type of parsing formula here. I've got an error budget component, I drop the SLI in the middle, and then I've got a period. And the nice thing about this is you can adjust the period as needed, up or down, and that will suit different stakeholders. You could have a 7-day period for engineering teams, you could have a 1-month period for say product managers, and you could have a once a quarter for executives. So you can take this same SLI and vary the time period, and now you've got SLOs for different stakeholders. And this is what I started to roll out across the organization. So to sum up what I've shown you so far, there's a few points on getting thousands of engineers on the same page for SLOs and error budgets. First, you need real-world examples. Most of the published books out there don't go into too much prescriptive detail and don't give you complete examples consistently, and you need to have those. Because we all know that engineers are kind of like lawyers. They're going to look at what you present, and they're going to try to poke holes in it. They're going to ask questions, look for edge cases. So you really need to have that simple and buttoned down. Second, present formulas for each of these entities, which can be parsed easily by humans and machines. And third, you've got to be really detailed and consistent. I see so many SLOs out there in the industry examples, which leave off the time period, which is a very important piece. You might say, well, the time range can be whatever you want, but then it's not an actual SLO or an air budget. Folks might say like, well, 99% of my requests are under 500 milliseconds. What time range is that? Is it over 5 minutes? Is it over a week? SLOs are about prioritizing engineering resources. So when your air budget is exhausted, you're almost past the time at which you need to focus on reliability. And so it's really important to pick that time range. This is a monitoring conference, so with monitors, a lot of us are used to time ranges like within a minute. If my error rate exceeds 1% within a minute, I've got problems. So SLOs are a little bit different. They're about longer term and categorizing the reliability service over something that defines customer happiness. So we've looked at some example SLOs that most engineers can parse and memorize, and which engineering managers and product managers can use to correlate user happiness with. In most cases, that happiness means that your service is available and that it's running fast. We can take the formulas I just showed and extend them to cover both conditions at once. So here's an example SLI, SLO, and error budget, which covers both latency and availability. So I'll break this down, and most of you probably already know what this stuff means. If the page result is not a 5 something something, fail well, or the GitHub unicorn, that request was considered to be a good request. And it's also served in under 100 milliseconds. That's our SLI, which we can add a success objective of 99.95% and a time range of 7 days to be evaluated on. Now to get the error budget again, we subtract our success objective of 99.95% from 1, which gives us an error budget of 0.05%. So 0.05% of our requests can either be too slow or an error, or both. It's simple to understand, and as I mentioned, you can create multiple SLOs for different stakeholders just by extending the time range. Now, on the point of the success objective here, I have 99.95% listed, 3.5 nines. Realistically, this is what enterprise customers demand these days. This means that out of 1 million requests, you only get 500 requests that are too slow or return a fail well. At my day job, we had a highly revered engineering SVP named Jason Smale, so we called 99.95% Smale's number. If you're at scale, you should look to this number as your success objective. So at this point, we've got some example formulas for SLIs, SLOs, and air budgets that should be relatively easy for folks to understand and straightforward to implement with most tooling solutions out there, both open source and commercial. And you've got a metric name, metric operator, and a metric value, which you can map to queries in Graphite, Prometheus, Datadog, Circonus, any one of the multiple solutions out there, Honeycomb too. So of these components of latency and availability, availability is pretty much the easy one. Simple example is I've got a 500 response, often saying, sorry, a problem occurred. That's easy to measure. There are some differences of opinion, like should I have a 400 be an error? Well, I guess that depends. If you roll out a change and you see a huge spike in 400s, you probably did something wrong. If you see a few intermittent measurements of 400 responses, the user's probably doing something wrong. Latency, however, is more difficult to get right at scale. And when I say get right, there are two aspects to that. Does your measurement have the right precision for your scale? That is, if I have 1 million user requests, can I generate a latency aggregate, which means I'm not leaving more than a few dozen users out? The other aspect is accuracy. Is my latency aggregate for an SLO or monitor actually correct? Like if I've got 99.95% and I measure 99.93, is it plus or minus 0.005? Is it plus or minus 0.001? What are those error bars? And like so many cases I've seen, the answer to both is no. And let's dive in. So back to this graph. What this is an RRD graph, and it measures network usage and calculates the 95th percentile over the certain time period. Now, back around the dot-com boom in 2000, these were very used, heavily used. If you had a co-location, your network provider would say like, okay, I'm going to bill you, $1,000 a month, and you're going to get 5 megabits at 95th percentile, meaning that if you take all of the 5-minute slices in this data set, you sort those, and if the 95th percent slice was above 5 megabits, then you get an overage charge. I just remember that being a dreaded thought in my head running a colo. And this really, I think, popularized the approach of using percentiles, and which would be seen 10 years later in 2011 with the advent of the StatsD protocol developed by Etsy, which provides P95, P99, P90 as latency aggregation metrics. I wrote more about this in a blog post I published a few months ago. That's the link to it. This is a slide from an SLO presentation, Latency SLOs Done Right, that I gave at SRECon 2019. And it illustrates a common mistake. These are 2 different latency distribution profiles, which are meant to represent service nodes that are behaving differently. The blue distribution represents a bimodal latency profile with lower latencies than the single mode red latency distribution. Basically, this could be 2 web servers, one performing well in the blue and one performing not as well in the red. And if we average the P95 values that we derive from each of these distributions separately, we get an answer of about 430 milliseconds. But if we combine the data sets and calculate the P95 of the composite data set, we get 230 milliseconds, an error of almost 100%. Now, most monitoring and observability tools out there will happily let you use an average function for percentiles generated from different hosts, nodes, or clusters. And if the distribution profiles are the same, you've got the same data in each, that works. But in the real world, that almost never happens. It's when your services are having issues. If you've got one node, say out of 100, that's behaving like the red node right there, that you're going to encounter errors with this approach. And that's a problem with percentiles. And when you encounter these errors, averaging percentiles is going to mask this. So try to avoid this mistake where possible. And a lot of it depends on your tooling and how you collect that latency data. So we should be avoiding using percentiles as a latency data source and instead collect latency measurements as histograms. These are 3 different histogram implementations. This is a talk from, or images are from a talk I gave at SLOconf earlier this year. I think it was April, which feels like a year ago. 3 types of histogram data structures. The first on the left is the open histogram log linear format developed by Circonis, where a latency measurement is slotted into one bin, sometimes called a bucket. The middle image is, some folks might be familiar with, is the Prometheus cumulative histogram, which, if I've got a latency of 125 milliseconds, it's going to record an entry for each of those buckets, moving down towards 0. And the third is something I developed at Zendesk called an inverse cumulative histogram, which is an opposite approach to the cumulative histogram. You can implement any of these with most monitoring and observability tooling. And what I've shown here is how you can do that with metric tags. So let's take the first example with the open histogram. If I've got a measurement of 125 milliseconds, I can assign a metric tag. I can record that as a counter, and I can assign a metric tag to that saying, oh, the measurement was greater than 100 milliseconds, but less than 200. And the exact buckets will vary. Similarly, I can do that with the cumulative histogram. I'll have to assign tags like less than infinity, less than 1,000, all the way down. So the faster my requests with this approach for the cumulative histogram, the more tags it will have, which can become a cardinality issue. And that led me to derive this inverse cumulative structure where I'm assigning tags based on what the request is greater than. So if I have faster requests, I need less tags. And so that kind of solved the cardinality issue for me. Unless you're using a native histogram storage type, like with IronDB, I think there's a few other out there like Atlas or Argus from Netflix and Salesforce. There's some native data structures out there for a time series database that will actually store histogram data. If you don't have those, you could use this metric tag approach. Now, the approach I showed on the previous slide is what I would term as raw histograms, where we keep account of samples for each bin for each time slice. And with that approach, we can sum up different latency bins across an arbitrary number of nodes and time windows. And we have, because we're summing up the raw data, or at least the counts, we have errors that are effectively zero. There's a few other approaches out there to histograms, such as sketches like the GK sketch, Datadog's DD sketch, and there's approximate histograms out there, such as T-Digest, which stores approximates of distributions using centroids. I think there's a good talk on this tomorrow. I'm looking forward to seeing it. So these two charts I took from the CircLLhist paper, which described the open histogram log linear format. And there's two different workloads here on the top and the bottom. And these, on the left, these represent error percentages for the workloads across quantile values. You'll see your P9 or your P99, your P90 across the x-axis. So overall, you can see, the log linear histogram, the red one at the bottom, did really well, had really low errors. The other, the digest, I think Guillotine's is on there too, as HGR and T-Digest. Those did fairly well also. But there's a detail that's not in these charts. If I'm just using this, any one of these data structures to record performance values for a single node over a single time period, you're going to get these types of errors which are bounded. And they work very well. However, when you start to use sketches and approximate histograms across multiple nodes and multiple time windows, the errors can become somewhat unbounded. And there's not a lot of information out there on just how unbounded. So, it's a difficult question to answer, like what kind of errors you get there. So, which is why I recommend just using raw histograms, which store the sample counts per bin, and you just avoid that problem entirely, ensuring that any of the aggregates you generate from them to use for SLOs, say if you want, my P99.95 will be as accurate as possible. So try to use raw histograms where possible to record latency data, and then use those to power your SLOs. And if I've got an SLI that says, or an SLO that says, I want 99.95% of my requests under 500 milliseconds, you can just use the 500 millisecond bin for this and count up all the requests. The math is really easy. The math for sketches and digests is more complicated. The interfaces abstract some of that out. But when you're using raw counts, the error, you can be relatively sure that the error is close to zero for very large, even small data sets, including very large data sets. You can get, arbitrarily high precision because you're taking a sum and you're essentially summing up all the samples under a certain threshold. It doesn't get much simpler than that. Now, one common question I've gotten about SLOs and error budgets is, okay, this sounds easy for a monolith, but how do I implement them across a distributed service architecture? Well, one approach is to use an SLO and an error budget for each service, and that includes third-party vendor services. The errors generated at the backend services, meaning towards, away from the request source, are additive to the middle tier and edge tier error budgets in SLO. So in this example, we have a third-party service which generates a 1% error rate, a backend service with a 0.1% error rate, and a mid and edge tier service, each that are generating their own 0.1% error rates, exclusive of any downstream generated errors. The backend service with a 1% error budget uses only 10% of the budget, but the mid-tier service, because it's accumulating errors from the backend services, has an error rate of 1.2%, and it exhausts its error budget. Just like the edge tier, which sees a cumulative error rate of 1.3%. And the goal with something like this is not to assign blame to different teams, it's to prioritize reliability work. In this case, the third-party service needs to have reliability work prioritized on it. And that could mean trying a different service, assigning a cache, or just putting engineering resources to it. And part of the reason why we want our data on this to be correct is because prioritizing engineering resources is expensive. And we want to know that when we're doing it, we're actually getting some value out of it. And that's it. Thanks, folks. I could take some questions.
Awesome. I think we've got some time for some questions. Any questions out there? Never see that spotlight on it. Anyone? Oh, here we go.
That's a cool concept, the multi-service SLO. How does that, can you say how that might roll up to an application? A bunch of underlying dependent microservices? And could that? Maybe I'm asking for too much.
So one approach is measuring the error rates. How would an approach like I showed on the previous slide with multiple error badges roll up to an application? So in this case, your application could be the mid-tier. You can measure error rates that are generated just from that application and construct your own error budget for that application and measure each of the downstream components. Or you could just measure the error rate coming out of that application via as measured from the edge tier. And that's one approach. And then you could say, hey, application team, you've exhausted your error budget, go figure it out. And then they could go look at each of those downstream pieces. So we like to, what I've evangelized is each team owning a service should have an error budget and an SLO. And it's on them to prioritize their own reliability work, if they're, say, approaching like 80% of their error budget used. Thank you.
Cool. Any other questions? Nothing. All right. Well, we are running just slightly ahead of schedule, which is great. So because of that, we'll start the next session. So we'll start a break right now. We'll start the next session at, 10:55. So we'll still kind of hold it to about a 30-hour break. Feel free to grab some coffee, check out sponsors, and then meet us back in here for 10:55, and we'll have our next speaker, Joy, this morning. Thanks, everyone. we got some coffee back there. We're trying to push the pour-overs. Jason never wants to be out of coffee. So in preparation for this event, he was expecting there was going to be a lot of coffee drinking. And I believe he purchased something around 20 bags of coffee for the pour-overs. We are now through about 1.5 of those bags. So if you could drink those to your heart's content, it's entirely possible that those tickets that you have, the elusive prize at the end, could be a bag of coffee. So.
I will accept that.
All right, so we're going to kick off the next couple of talks. We've got some sponsor talks as well after with Catchpoint, AppDynamics, and Timescale. Before that, I'd like a big round of applause for Joy.
Hi. I'm so happy and excited to be here. This is hands down my favorite conference because I am such a nerd for this stuff, which I think my talk will probably also demonstrate for you. So thank you. My name is Joy. I'm the Director of Infrastructure Engineering right now at a company called StrongDM. I have been working in systems and network engineering since 1996, when I dropped out of my art degree and just kept working in the computer lab at my college. So in this talk, I'm going to go through my thought process for building and maintaining a highly available system. It's high level, it's not specific to any given technology. What it is the talk I wish I had when I started out, and it's the talk I sort of end up giving to like junior engineers who are coming into the DevOps space. We have so many tools and services available to us now. We can truly build a service that heals itself with minimal human intervention and without the huge overhead that used to come along with this. Something that I want everyone to take away from this is, don't underestimate the importance of your time. You do not deserve to be woken up or pulled out of your life for spurious alerts. The work of systems engineering is the work of putting things in place to prevent that, not rote tasks that you haven't gotten around to fixing in a systematic way. One way to quantify the value of your time to your employer is to identify how much a person hour costs. I have done this. It was super interesting. If you can ask your people ops team, your manager, tell you how much they pay for an average engineer. It's usually more than your salary. It includes taxes and benefits. And if you figure 40-hour weeks, maybe 48 weeks a year, and math it out, about $150 US in salary works out to about $100 an hour. So there are no shortcuts to resiliency work. And so if you don't spend this time at the beginning, you will have to spend it later. In the meantime, you'll have a lot of interrupts, fires, and they will suck the life out of you and everyone else who has to maintain this brittle system. That will make your team brittle, and you will lose its ability to solve problems and build resilient systems. So let's set the stage with some context. What is the biggest problem that you have when you're starting a business, when you're at a startup? You don't have enough people and time to do the work, and that problem never goes away unless the business is failing, which I also know about, but we're not getting into that here. But if things with your startup are going well, you are going to keep growing. More customers will mean more load on your systems, and as things grow, you'll run into different problems at different levels of scaling. So if you don't start smart, or if you get smart, you will be behind all the time, and you'll be playing catch up, which is incredibly difficult for several reasons. You won't be able to turn around features your users require. You won't be able to fix minor bugs that your users need fixed. You will burn your people out, and high churn will then burn more people out. You won't keep good people, and then you'll be flailing even harder. And teams will spend large amounts of time building around problems instead of solving them. So to avoid this, let's discuss a few pitfalls and how to avoid them. Adding complicated pieces of machinery at the start that you don't have a clear need for. Folks tend to make assumptions about requiring certain technologies when realistically they are adding complexity for little purpose. Kubernetes is great, I'm not slamming it, but do you actually really need it? Or do you just need a simple autoscaler? Start as simple as you can get away with and add complexity as your needs evolve. You can also start with a service that requires minimal configuration effort on your part, like Render or Heroku, to defer complexity, but make sure you understand their reliability story and be prepared to deal with not controlling that underlying service. Another pitfall, not writing up configuration as code right away. I know it's easy to wait on this. I've done it myself, but do yourself a favor and don't. Once you have your service working, code it up and start it up again and again and again. Do it until you can bring up this environment working from scratch. Because, if you can't start this with production, you can get it going with your dev environments, and that will help you get to that place. I use dev environments not just for application development, but also for infrastructure development. Another pitfall, not documenting what you were thinking. You can figure out a lot by looking at code, but you will know even more if you have a written overview and a diagram. You can also document your architectural decisions so that you know who to blame in 2 years when you're wondering why things were done a certain way. Hint, it was you. There's something called architectural decision records that are a good framework for thinking about this problem. I'll have a link to them in my references. Another pitfall, not instrumenting your code. You don't need to go overboard, but give a thought to what you want to see happen in your system. What will help you troubleshoot when something goes wrong? Sitting down and thinking about this as opposed to just making assumptions is a really good way to understand this. Do you need to record latency and errors in your API endpoints? Maybe you should instrument for tracing right off the bat if your system's fairly distributed. Structured logs are good, but sometimes you also just really need good metrics. And let's pivot to some fundamentally good ideas. These are things that'll give you confidence in your decisions and will help you. You should research the systems you want to bring in. I know it sounds obvious, but make sure that no matter how excited you are, you know the downsides of the system as well. I have been guilty of this. Understand how it fails under load, how it handles unexpected data, and how to recover from failure. Think about what it was designed for initially, and then think about how well your use case matches up to it. And make sure you either have existing expertise on your team, or you have to invest in making sure folks can learn any technologies that are new to them. If you pick something good but complex and hard to learn, it's going to be hard to maintain. I know, because at one point Heroku hired all the Erlang programmers that we could, and then we couldn't find any more Erlang programmers. Make sure that everything can self-heal. If it doesn't, you better have a really good reason to bring it in, because you'll be on the hook for fixing it when it does break. Self-healing, let's talk about that. I think we all kind of have an idea, but giving your system the ability to heal itself without additional human intervention. Self-healing assumes that components of any given system will fail for a variety of reasons. Entropy will come for us all, and we need to think about how to automate away that constant fight. If you have a large-scale system, at some given point, everything's going to be in some minor state of failure, just like our bodies. One of the best descriptions of resiliency and self-healing I've heard comes from Dr. Richard Cook's talk on the resilience of bone and resilience engineering. I'm putting a link to that, again, in my references for the slide. Seek it out if you can. It's amazing. So here's some basic services that you can use to bring things back to health. And again, you're probably already using them, but it's good to really think about this. So auto-scaling groups for stateless systems. You can use metrics, absolute numbers to bring your system pool to a healthy state. Sometimes it's even just like an auto-scaling group of one, and you just have like a service that doesn't need to be like very available, but mostly available. State machines. For stateful data, if it requires more care and automation, because you can't lose that data, you can't just shoot it and let it come back. State machines are a lifesaver. They allow you to attempt standard processes and then feed back into that loop. I think we've probably all thought about them a little bit, but I've seen them work really, really well at Heroku to automatically fail over their databases, and they managed to get, at the time I was there, 1 million databases with a 10-person on-call rotation. And when these tools fail, you need to alert an adult to let you know what's going on. But you've already gotten most of the easy stuff out of the way, and then you can actually think about how to solve things in a creative way. Another option is the dead man switch, something like deadmansnitch.com. You need a watcher for your watchers. This is useful for canary monitors, other automatic systems like your state machine to make sure that they're running. Because there's really nothing worse than being like, well, why did my automated system go down? It should save itself. Why didn't it alert my canary? Oh, my canary's down. Come up with several systems designs, at least in early stages. Everything has some positives and negatives, and even if you have an inkling of what the right solution will be, keeping a broad outlook means you can incorporate good ideas you wouldn't have had if you didn't force yourself out of your comfort zone. There are so many times where in my hubris, I'm like, nah, I know I'm gonna build this system. Give it to someone else, and they're like, have you tried this, this, this? What about this? And I'm like, oh, no, okay, thanks. In that same vein, asking for feedback from coworkers and other folks is appropriate. You really need to remember not to get defensive and embrace feedback as a gift. Other people are sharing their knowledge with you, that's awesome. You don't need to use their suggestions in the final product, but you do have a chance to learn something new. So here's some concrete steps I follow when I'm architecting a system. I kind of took this from my last role where I built out an API for a spatialized audio. I usually do this visually by diagramming a system and walking through it as traffic would traverse it. But you always have to start with your user story. You think about who needs to use the system, what do they need to do, who will be responsible for maintaining the system, and what's their knowledge base, and what are the inputs and outputs of the system. This is basically product management, but we don't do it very much in infrastructure, and we should. For instance, here are a bunch of questions you can ask yourself and your team about different components of a system. Okay, now I'm just gonna go with a barrage of questions. Do you only need an API? What about a graphical user interface? Can you decouple those things? Can your GUI just talk to the API? What's the entry point to the system? A load balancer? Something else? How does it detect health for nodes and its targets? How do you handle a load balancer outage? Is your load balancer in only one region? Can your API or control plane layer be stateless? How do they pass on their health status to the front end? What happens when one of those machines fails? How will that system heal itself? This is why developers hate me, by the way. Do you need other components to connect to? You probably do, and they probably need to store state because, I mean, come on, it's not real if it doesn't have some state. You might need to stream a lot of data. Is that going into a clustered system? What happens when any given node in the cluster goes down? Are there any special nodes in that cluster? How much data do you have in your system? And how long will that take to replicate or replay? How will that system heal itself? What about a database? Again, is it a cluster? Where do the writes come into the database? What happens when that fails? Do you have a replica locally? Do you have a replica around the world? Where are your backups? How long would it take to restore them? Have you tested them? Where do reads happen? Do you need to read and write from the same or different systems? If the main writer fails, how does it get replaced? How can it self-heal? Again, I'm gonna keep going. What about caching? How often does it refresh its state? What happens when any node in the caching cluster goes down? Can your system handle load without the cache? Or would it be overwhelmed to start from a cold cache? Can you scale for this? If you moved your application somewhere else, would you need to persist the cache or could you just start over? So, you gotta take yourself through all these questions for every component you add to your systems and be methodical. Maybe you're using a service with Google or AWS that will handle this on the back end for you, which is awesome, especially if you're a small company just starting out. But in that case, you're not off the hook. You need to research how those systems handle failures and how they report them back to you, and thus your other systems. I have certainly been guilty of assuming that Amazon does something the way that, in my mind, is the only logical way to do things. They do not always do that. And then interconnects. Obviously, the system isn't going to work, especially if you got microservices or something like Kubernetes, or if you don't have network. What happens when a client loses its connection to an API host, or the API host loses its connection to a streaming server? How do these services report an error? What happens on a timeout, or when a server accepts a connection and then just doesn't do anything with it? Maybe because it's crashed, and metaphorically it's sitting glassy-eyed on the couch, like I do sometimes. Take yourself through these interconnect cases the same way you did for the self-healing cases. And then, with all of that in mind, now is the time to talk about observability. How do you observe in your system and alert if things go wrong? As we all know, it's the unknown unknowns that'll get you. Thinking through everything will put you in a good starting place, but you will have problems you didn't anticipate. Remember that your system is both individual components and the sum of its parts all working together. You'll want some way to know that the users of your system are seeing what they should see. This is where the concept of a canary or synthetic tests come in. The goal is to set up something simple, ideally coming from outside the system, that follows the path the customer would likely follow. This can be quite simple, and probably should be. A lot of people use functions as a service or a third-party platform to do this. The things that you want to measure, we all know, my holy trinity: availability, does it respond, latency, and how long, and errors, is it correct? Think of it as a sentinel that should alert loudly if something goes wrong. And if you have no other alerts, this is a good place to start. For a long time, I had one alert. It was a canary, because I was like, well, the rest of the system's pretty simple, but what I really need to know is it working? If your canary isn't reliable, your system isn't reliable. You have to have one alert you can truly depend on. It's way more valuable than several you're not sure of. As a bonus, this is usually what you end up figuring your SLA off of, assuming you have customers with SLAs in their contracts. So that's the warning light, or as my stepdad who worked for GM liked to call it, the idiot light. But what about individual components? And this is where you're thinking more granularly for metrics and alerts. This is where folks run into problems with noisy alerts, the kinds that keep you distracted, frazzled, burn you out. My rule of thumb is actually that I would rather have no alert than an untrustworthy one, because I have seen an untrustworthy alert get ignored, and then outages happen, and everyone's like, well, why didn't you pay attention to that alert? And it's like, well, how would you expect me to? 5 times out of 6 is a bullshit alert. If you currently have those alerts and you can't get organizational approval to fix them, this is where that formula for the engineer's time comes in. Figure out, how much time do I spend? How much time do my colleagues spend? And how many of my colleagues spent how much time fixing this? You can, put it in a spreadsheet, show it to your manager. Suddenly it starts looking a lot more sensible to take some time for those. But you do need to see how your system's components are faring. Before you put alerts on it, make sure you have good metrics that actually show you how each system is performing at baseline. Don't throw every metric a system emits at a dashboard and gaze upon it. It is too much for a mere mortal to bear. You'll want to take what you learned walking through the system, remember how we were thinking about all the components, and consider what is important based on what I know about the system and how it acts. For databases, you want to look at things like connections. You want to look at locking and query performance and storage. Obviously, this isn't exhaustive, but think about it. Queuing systems like RabbitMQ or Kafka or SQS. How are things moving through the queue? Is it backing up? Is there a regular pattern? For APIs, what are your most used endpoints? What's slow, and are there any errors? For caching, big one, what's your cache hit rate? Is it providing you benefit? And for system level metrics, like CPU or memory or disk usage or I/O or inodes, you don't need all of those front and center. You should consider what's most likely to be a bottleneck on a given host based on what the service is doing. Does a certain service use a lot of CPU? Like, a spatialized audio mixer? Is it using I/O? Is it, writing data to disk? Could it write and fill up a disk? You gotta bring those front and center. Keep the other system level metrics tucked away until you need them. And of course, metrics are one part of the story, but they're just little plots of data on a graph. Another thing is logging, which of course is a tale as old as time. There are so many options for centralizing and analyzing logs. But what I'm here to say is you just need to consider what you plan to use your logs for and build out that system based on your use. First, make sure you have structured logs, some sort of structure. If you're going to parse out useful information from your logs, you need to have an automated way to analyze them. Because, while I've spent a lot of time in my life watching logs scroll down, journal control-EF is probably one of my most soothing ways of getting through the day. I don't think that, that's a really sustainable solution. If you need an audit trail, like something that, you can basically show to a compliance or a security person, you need to send that to a tamper-proof place, ideally has good encryption, authentication. That should not be the logs that you probably need to look at when you're troubleshooting a problem. That's something separate. Troubleshooting, you probably have a different set of needs. If you have a high log volume and you want to find a needle in the haystack, I'm going to shout out honeycomb.io for sampling logging data, allowing you access to slice and dice it and look for unusual patterns of behavior. But there's other options too. You can use an elk stack if you want to go open source, or CloudWatch logging if you like to live within AWS and are uniquely headache-proof, or something like Sumo Logic if you want to pay a third party to not worry about it. But no matter what you do, make sure your logs make sense. Agree on logging levels and use them. Consider it a major bug when you're overlogging, because overlogging can take down your entire system. I wish it wasn't the case in this year of 2022, but it is the case. If you fill your disk, your service is dead in the water. Still, if you can't log to an overloaded central logging system, that can cause back pressure, take down the service. And even if you haven't, if there's anything else going on, you have a rain of useless messages that you have to wade through. So this is worth putting an effort to fix and consistent housekeeping effort to clean up, because they can save you when nothing else can. Okay, tracing. Okay, yeah, we've all... Sorry, I had COVID 2 months ago, and I'm still coughing. Isn't that awesome? It's such a great virus. I love it. So tracing can be great. If you've ever struggled to put the pieces of a request together as it travels through a complex system, I'm sure you can appreciate tracing. I don't need to be a tracing cheerleader here. Everyone's a tracing cheerleader here. But it's really logs with a lot of extra useful context. It's like following the entire track of your system. That requires code instrumentation. That will require collaboration between your application developers and infrastructure engineers. Good reason to keep those lines of communication open. And also to note, it can be resource intensive to run and store traces. So you might want to ensure you can turn it on or off with a feature flag. And you want to think carefully about how much data you collect and where you will store it, just like your logs. Remember, don't let your observability turn into a point of failure. For a really good story about this, you can check out Amy Tobey's super awesome blog post, OpenTelemetry and the Ghost of Provisioning Past. I will also link it in my references. So visualization and automation. So now we're talking about all of these. How do we incorporate them? Sometimes you want a human to look at your graphs, your logs, your traces. Sometimes you want a machine to analyze them for you. And how should you decide? First, you're not going to be one side or the other. Both are very useful. As a human, we can use our own intelligence to pick up on oddities that a machine might miss. We can get an understanding of what usual behavior looks like, and you can see what's maybe gradually changing over time. Having a habit of looking at it, reviewing it with your team, it's extremely helpful. It feels a little lo-fi and old-fashioned sometimes, but it's also useful. But as humans, obviously we can't look and process everything. We're not good at doing simple things on a regular cadence. That is what machines are good at. And if there's something you need to be alerted on whenever it happens, in the rare cases that you do actually need to do that, it needs to be automatic. The most important thing to consider, though, when you're setting an alert, when you're looking at a system, when you're building this out, is thinking about your customer's experience. They are the reason you have a service at all. I'm not going to get into SLOs or SLAs exactly. Obviously, other people are doing it and doing it really, really well. That's beyond the scope of my talk. But you need to remember that if your customer is having a bad experience using your service, they will probably leave and you will not have a service for long. So let's talk about another aspect of self-healing. Again, something that I'm sure we all have access with or experience with, service discovery. If you have a self-healing system, nodes that'll die and need to be replaced, you need to be able to get them back into service without manually adding them back to a static config. Surprisingly hard, even though it's been a long time. Service discovery, there's a lot of depth in this topic, and I'm just going to talk about a few high-level things and maybe give you some more ideas for, again, like what to consider when you're using different components. So, DNS, I love it. You know, it's a lot easier, I think, sometimes these days to mess with DNS than it used to be. I remember bind and always forgetting to change my serial number and then having to go back in. But right now, I gotta say, it's still there. Tried and true method of service discovery, DNS. Obviously, you're taking a name and you're pointing it to an IP, or another name, which is also pointing to an IP, or a group of IPs, or something. And round robin DNS is totally a thing, and a very reasonable way sometimes of doing service discovery. But there's things that you have to consider with this. One thing, when a host dies, probably ungracefully, you need to make sure that you're taking its IP out of your DNS record. How's that going to happen? Well, make sure you got something. You can set up health checks in Route 53 at least to see if something is responding before it returns it as part of a record. Again, you need to make sure that that is working properly. And you don't want to get your record really bulky, because then even now, if it goes too big, you're probably going to actually see some systems problems. DNS can take a while to update. Remember, DNS is a system that basically only works because all of these sorted systems across the internet agree to do the same thing, and they don't always do it right. You'll need to make sure your service can handle cycling through bad IPs before it gets to a good one, cleaning up that record, and also, you could consider assigning a static IP to your service, like an elastic IP, like if it's small, swapping out the IP when the node fails. That fixes DNS update time, but you still have to think about, okay, how is this reliably going to assign itself to its new IP? So load balancer, DNS, obviously, load balancer, second old school. Things to consider, hosted load balancer, like ALB or NLB, something like that will scale automatically, but won't scale automatically extremely quickly. Or if you're running something yourself, like Nginx or HA proxy or a piece of hardware in the data center, you still really have to think about scale and what your peak is going to be. And if it's auto-scaling, how long it's going to take to scale that. You need to think about what happens if your nodes start dying. Like say those stateless nodes need to just suddenly start getting replaced. Like what is that going to do to the load balancer? How are you paying attention to that? If you do load testing and chaos testing, I think that's one of the most valuable things that you can see is how this works. And of course, if you have a load balancer failure, you're probably having a really bad day. And then let's talk about service registries. Again, whole additional service that your service depends on. And suddenly that service is probably the most important service, because if you depend on something and then nothing, and then that service is having some unknown problem, your other services can't heal themselves or can't even start. I'm not going to get into detail, but yeah, remember, services that you need to use your services are the most important part of your stack. So that's about it. It's wrapping it up. Thank you for listening. I hope that this gave you some good ideas for the next time that you find yourself having to build out a new system, or a new component of your system, or even just thinking about like how you want operations to look like in your company. Don't sacrifice your life and mental well-being to a bunch of ungrateful bits of silicon. That's the most important.
Got time for maybe one or two questions. If there's any questions from folks in the audience? Anything? Make sure I don't miss anything. Give a holler if I'm missing. No? All right, great. Thank you so much, Joy.
Thank you.
All right, we're going to have a few of our sponsors come out and talk. Our first sponsor is going to be Catchpoint. I just have to say, I don't know what the view was like here. Joy's slides were so amazingly colorful. Just loved them so much. There's a monitor screen in the back that is probably older than I am, and I have a lot of gray hair to tell you how old I am. And it is as deep as it is wide on the TV screen. It's very old. And every color was just like so incredibly bright on that. It was amazing to see. So, all right, come on out. We'll get you plugged in. All righty, big round of applause for Catchpoint.
Thank you so much. Hi everyone, thank you so much. So good to be back in Portland and the best conference about monitoring, observability, and whatever other buzzword we will come up with by the end of the day. Thank you, Jason, of course. So my name is Mehdi, I'm the co-founder and CEO of Catchpoint, but I'm not going to talk about that today. Been doing monitoring since '97, took DoubleClick down for 3 hours while I was responsible for monitoring, so I'm in monitoring purgatory for the rest of my life. I love monitoring. I love finding when things go wrong. But the talk is about the red dot. Obviously not this one. We came out of this pandemic, thank God. So work has been insane. We doubled in size, including my belly, since the pandemic. Shift from office has been terrible. The you're on mute is killing me. But I had to pick up some new skills because I used to fly about 500,000 miles a year, and now I was home. So I tried cooking, and I'm pretty good at that. I tried stand-up comedy. My wife didn't appreciate the scented toilet paper in 2020 when we were running out of toilet paper. I opened and closed a barbershop in one day. My son is not talking to me. We did a lot of Legos. One of them was to beg for forgiveness for one of those haircuts. And finally had time to build my rack, and I did a Pi-hole cluster, and that was awesome. So I had a good time. But then at 9 p.m. on February 17, I received a phone call. It's like nobody calls me at 9 p.m. unless there is a crisis. And hey, Mehdi, Dr. Jill here. Are you alone? Are you sitting? And when a doctor tells you, are you sitting, typically I don't think it's a good news, right? Quick rewind, a few days ago I went to do my physical, blood work, all that good stuff. And for those that love time series, this is what it looked like, right? So I had a few years of good data, and then something blip. And the phone call was like, hey, we spotted something on your x-ray. We don't know what it is. It doesn't belong there. It looks weird. We need to dive into it. And she doesn't have Datadog, so it's very difficult, right? It could be from smoking. I used to smoke. Could be genetic, but they were dealing with an unknown kind of thing, and we've all been there, right? So obviously my first reaction was like, your x-ray machine is broken. We need to do another one, right? So false positive. But I used to do this for a living, right? So I went into my war room. The application owner is me. My oncologist was the subject matter expert, my incident commander, my generalist, and then obviously my operation person was going to be the surgeon. So we need more data. We need to clearly identify what this is. So a lot of you went on Airbnb and moved from one place to another. I also did the same thing, except my CT scan and MRI scan were my Airbnbs. The PET scan was really funny for those that ever went and did one. Anyway, so I know how to read this in my sleep, right? Waterfalls, that's what we do for a living. But this one, very hard to read. By the way, this is the most naked I've been in front of any audience. This is literally my PET scan, CT scan kind of thing. So they didn't know it was cancer, but we still had to do and get a second opinion. So 2 different tools, 2 different doctors, etc. Okay, it is what it is. I called it Bob Norris, the Marlboro guy, had to stop smoking. The irony of all of it, because we're in the synthetic monitoring, is even the doctor that did the surgery on me was a freaking robot, right? So root cause, mean time to innocence, was smoking. But the recap is this: get your house in order. All the stuff that we do for a living, playbooks, run books, all of that stuff, applies also to your house. Make sure you have that. And do not ever, ever ignore a red blinking dots, even if you think it's a false positive. Thank you.
Yes, I've never actually seen anyone put their actual scans on there before. It's like, yikes. I don't know if there's any medical folks in the audience here. All right, next up we've got AppDynamics. Actually, we've got these two live. All right, round of applause for AppDynamics.
Thank you. So my name is Gerald Dahl. I am a senior advisory engineer with AppDynamics, and I want to introduce you today to AppDynamics Cloud. We just released it. It's our new observability platform for cloud-native environments. It's a totally re-architected environment with a different framework than a previous AppDynamics product. The idea here is we went after the complete stack of information, so metrics, events, logs, and traces into a single environment, and put those into a single context so I can look at it. And this, what I'm showing you right now is just looking at the different levels of infrastructure, Kubernetes, APM. I can drill down on the services, produce my service map, show the context on all of those from their going into what we're doing here. But we're pulling this in not just at, for small environments, but for large scale. We're really focused on, managing the complexity around Kubernetes and the cloud environments when you're talking, thousands or 10,000s or 100,000 pods of environments that we're focused on. So we can also then start to drill down into a specific service. So I can see that service. I can see on the left-hand side all the artifacts that are affecting that one. So what the service number of instances, number of clusters, the workloads, the pods. I can drill down into those, but also inside of here, I'm showing the endpoints that they're connecting to, the metrics that we're capturing from inside of that. And then I can drill down into the workload or to the cluster where I can start to see that the health rules that are showing up, if there's any health violations, will show up on the top. I can drill into those and see what they are. I can see the logs, drill into the logs and see the information from inside of there. And again, these are specific logs based on this cluster that I'm pulling in automatically into the system, and then getting down to the events, the pods, and giving that complete vision into the environment, so allow you to do quicker troubleshooting. Also allows us to leverage our anomaly detection to be able to pinpoint where the challenges are and where to address on that. We just released this today, so if you have any questions, please stop by the booth. We're up top, and be happy to discuss in more detail for you. Thank you.
Alrighty, next up we've got Timescale. Timescale DB, or just Timescale? Is it both? Timescale, the company, makers of Timescale DB. That's right. See, I can do part.
All right. Hello, I'm John Pruitt. I work for Timescale. All right. And I work on Promscale, which is an observability tool powered by SQL. Promscale allows you to store Prometheus metrics via remote write. We're also 100% PromQL compliant via remote read. And we've also got OpenTelemetry tracing support. This is all backed by Postgres that's been enhanced with Timescale DB. And this allows you to analyze your metrics and traces with SQL. The cool thing about being backed by Postgres and SQL is, everyone knows SQL. It's been around forever, and Postgres has a giant ecosystem of tools. So pretty much anything that knows how to use a Postgres driver and speak SQL can be integrated with Promscale. So Grafana, Jaeger, and any other tool is supported. What I want to show you is a taste of what you can do with SQL using tracing data. What we have here is a free to download workshop that runs in Docker Compose on your laptop. It's basically an absurd password generator built in services. So we've got 5 different services to build a password, random password. And each of these are instrumented to emit traces, and only traces, no metrics, no logs. Those go into Timescale, and Jaeger and Grafana are both configured to look at Timescale. So if you've used traces, you're probably used to seeing it in Jaeger. It would look something like this, and you probably look at one trace at a time. But what if you were to look at thousands of traces at a time? So right now, I've got this Grafana dashboard. It's looking at the last 15 minutes, and we're looking at 1,500 traces. Each of these panels is behind the scenes using one or more SQL queries. And so from these traces, we can build a histogram of latencies. We can find the slowest traces in this period of time. You can look at the throughput. You can look at the P95 latencies. You can build a histogram of latencies over time. But the coolest thing is you can look at every operation across all of your services and figure out how much execution time has been spent in that operation in the last 15 minutes. And by ranking those, you can see exactly where your bottlenecks are. So if my entire system is running slowly and I want to know why, I've got this pie chart right here that tells me the exact function to go to that's eating up all my execution time to go optimize. And what you're seeing here is that same pie chart built into a stacked bar chart in 10-second intervals. So not only can you look at the execution time for the entire 15-minute window, you can see how that looks over time within the window. You can start to see patterns. You can see this orange bar is periodically high, periodically slow, and periodically faster. You can also see that this red bar is not a problem, and then it's a problem, and then it's not a problem, and then it is a problem. So you start to see patterns that you would not be able to see looking at one trace at a time. And just to prove to you what's going on here, we can look at the SQL behind this. Not a big query. You do have to know SQL, but a lot of people do. So this is all looking at the time series aspect of traces, but we can also look at the tree structure of traces. So right here, we're looking at 5 minutes. We're looking at a service. You can pick the service and the operation, and you can see all of the operations that are upstream and downstream of that operation in real time, based on nothing more than traces, no documentation. If you push a change and you change this call path, it will be updated as the traces flow through. And this again is just SQL. So if that excites you, come by our booth upstairs, talk to us. You can also hit this QR code and download this demo from GitHub, run it locally on your system, and it's got all the SQL in there for you to look at, play with. Thank you very much.
Alrighty, we've got one last speaker before lunch. Quick reminder, lunch party in Slack. A lot of great options. I will recommend the chicken place Mama Bird, which I think someone dropped in there. Really incredible. There's only sauces with the chickens if you're a fan. Also, if you're trying to stay close by, Little Big Burger, which I think is right behind here. They have the quite amazing truffle fries. I'm sure there's no real truffle in them whatsoever, but the smell of them is just incredible. And then we will be back here at 2 o'clock. Am I doing that right? Yeah, so we'll be back here 2 o'clock after lunch for the afternoon sessions and talks. I'm gonna pass it off to Suma. Let's give a big round of applause for our next speaker.
Hi everyone, my name is Suman Karumuri. Today I'm going to talk about CalyDB, a Kubernetes native log search platform. My pronouns are he and him. So in this talk we are going to look at the motivation behind CalyDB, and then we'll talk about the architecture of CalyDB, and then we'll talk about how CalyDB solves those problems. So first, a little bit about me. I'm currently a senior staff engineer at Slack. I work on observability and performance. I love building petabyte scale observability systems. In the past, I've built systems in all 3 pillars of observability. In log search, I manage like Elasticsearch cluster at very large scales for a lot of companies. I wrote an in-house log search platform called Loglins at Twitter 7 years at this point ago. And on the tracing front, I was the tech lead for Zipkin project at Twitter, and I was also contributed to the open tracing spec. And I've built end-to-end tracing pipelines at Pinterest and Slack. On the metrics side, I've managed several large clusters running OpenTSDB and Prometheus, and I've also built in custom storage engines, Viz at Twitter, UV at Pinterest, and we wrote a recent research paper called Mark. Please check it out if you have some time. In general, I love building infrastructure and distributed systems. So let's jump in with the motivation for CalyDB. So just a little bit of overview. Logs are widely used for monitoring our systems. They're used for triaging issues, debugging issues, and fixing them. As a result, centralized log search platforms have become one of the most essential pieces of modern day systems infrastructure. So one of the biggest reasons we need centralized log search is in this cloud native world when machines can come and go anytime, or containers are being spun up and spun down anytime. Centralized log search systems aggregate those logs into a single location and provides guaranteed retention for those logs beyond the lifetime of the machine or the container. That is one of the biggest features centralized log search systems provide. They also provide other advantages. For example, they help you triage issues across machines, across services, etc. Further, these centralized log search systems also provide you consistent experience for querying your logs that are probably produced in different formats and things like that, but they let you access those logs in a unified format. So with that said, we collect a lot of logs at Slack, and we primarily query these logs in 3 broad ways. Okay? The first use case is search. For example, a customer service agent gets some magic string from a customer, and he or she goes into the log search system, puts the magic string in, and performs a full text search. Usually, this is generally a recent incident, so the queries are over like a few days to like a weeks or something like that. The second big use case is the one common use case that we are familiar with, which is aggregation. In aggregation, a developer builds dashboards and alerts off of their logs. Generally, these queries look like people are generally doing group bys and aggregations on their logs to answer questions like, hey, I'm doing a deployment. Is it actually going as planned? Is it causing any regressions? Are there any more errors than they were before? Are any of my endpoints slower than before? And so on and so on. These queries are also over days and weeks because you're generally doing week over week comparisons. So for both of these use cases at Slack, we recommend our users to use Elasticsearch. The third big use case for our logs is actually the analysis piece. In this space, for example, a data scientist takes these logs and computes a very complex aggregation of these logs, let's say to calculate a DAU or an MAU, which involves complex business logic, right? Or they can take these logs, join them with other data sets across the company to get other useful insights, right? And these queries are often run over weeks or months because you're probably doing quarter over quarter or year over year calculations. And for these use cases, we actually recommend that our users use our data warehouse. And sometimes these calculations are actually available in real time or needed in real time. For those use cases, we recommend users to use pre-aggregated metrics platform for those use cases. So what is the current architecture of log search at Slack? So today, our log search platform consists of Elasticsearch 7. We run over about 100 clusters running across 3,000 plus machines. And we recommend our users use data warehouse for long-term analytics. Currently, we manage about a petabyte of data, and the retention is somewhere between 7 and 9 days depending on the data set. we ingest about 4 million messages per second, which is actually only half the number of messages we produce. And we query our log data with over 1 million queries a day. The architecture of our log ingestion platform looks as the image here. So we have a common platform called Neuron, which aggregates logs from all the applications across our services and writes them to Kafka. You can also learn more about Neuron in the observability engineering book. In chapter 18, we contributed a chapter called Telemetry Pipeline Management, in which we describe Neuron. So you can read the chapter to get more information about Neuron. So from Kafka, the data is ingested into Elasticsearch via Logstash. And we have a parallel data warehouse ingestion pipeline built out of Seeker and Airflow that ingests the same data into our data warehouse. The data in Elasticsearch is accessed using Kibana and Grafana, whereas the data in the data warehouse is accessed via an in-house data warehouse UI. So here are the problems we have with our Elasticsearch cluster. There are like a lot of them. Elasticsearch is like death by 1,000 cuts, but we'll actually see 3 big problems with Elasticsearch. The first one is handling spiky log volumes. So what happens is during deploys or incidents, we often get like 10x the number of logs than we normally see. Sometimes we have control over this, sometimes we don't. For example, we launch a new version of Slack, new users, like in the middle of the night, users wake up in the morning and they're loading the latest version of Slack, and we have no control over when they do that. So we get a lot of logs, right? We get like these 10x peaks, and when this happens, our logs lag a lot, sometimes by minutes to hours. And as a result, when this happens, we lose real-time visibility into our systems. We don't know what's going on, at least from logs. Our metrics probably are up to date, right? So to actually overcome it, what we do is we peak provision our clusters, which costs us a lot of money. But peak provisioning does not solve all our problems. Here is why. So if you see on the right, on my right, you'll see that even just the organic growth of our logs itself, even though so the red line is where we provisioned ES at peak. But our new normal is more users logging into Slack in the morning. So we are producing more logs, and as a result, we have actually lagging again just because of organic growth. And again, this is something we have no control over, so this turns into like an on-call issue where you have to scale the cluster. The second big problem we have with Elasticsearch is high operational overhead and on-call load. So currently at our scale, cluster-wide operations takes days to weeks to run, and generally they impact read and write performance of the cluster when they happen, and they sometimes affect the stability of the cluster. Further, managing 100+ clusters to keep them all consistent and performing well is a tedious and error-prone job. We often have to write software that manages the software that manages Elasticsearch. So this kind of meta management software is kind of hard to write. Then the bigger problem with Elasticsearch, even when these are not the issues, is Elasticsearch seemingly has these single points of failure that stop the entire ingestion or delay the ingestion. So what happens is, let's say you have a slow shard or you have a single node that's failed, it kind of delays the ingestion, and now you have your logs are lagging. As a result, you don't have like real-time visibility again. While rare, we have seen cases where sometimes we have data or metadata corruption, which leads to data loss in Elasticsearch. This is very rare though. And the third big problem with logs is missing logs because of field conflicts. For those of you who are not familiar with the field conflicts problem, let me give you an example. Let's say there are 2 developers. One developer is writing an account ID field, is logging an account ID field as a string. The other developer logs the same field as an integer. What happens in Elasticsearch is, let's say these 2 logs make it to Elasticsearch. Elasticsearch depends on which log you get first, assigns the field type of that account ID field to the type it gets first. Let's say the string field gets to the log search engine first, so the account ID is a string. And what Elasticsearch does is for the next log where the account ID is actually an int, it actually silently drops the logs. This leads to lots of developer confusion because let's say you're a developer, everything is working fine. Tomorrow, some other person writes the same field in a different format. Now your logs are not there anymore. And Slack has hundreds of developers working across millions of lines of code, and this can happen anywhere in our system, and it is super hard to control. This also used to lead to mapping explosion. So what we actually did is we used to get a lot of on-call overhead too. People used to say, hey, like I'm writing these logs, why can't I see them? And often it turns out to be an issue because of field conflicts. So what we did is we did like a bunch of work to institute strict schemas in the logs we produce from our applications. In strict schemas, you actually set the type of the field when you produce it, so users cannot, it's basically a logging library that also ensures that the fields are of a certain type. So this adds another layer of schema management to users, which slows them down. But while this is a good solution that works reasonably well, there is one downside to it, which is that we only can do this on some parts of the code we control. For example, there are large parts of our logs that we don't control, that are produced by systems we don't control, like third-party software or open source software, and field conflicts are still an issue in these systems. So in summary, managing Elasticsearch is actually like managing like a race car, you know? Because Elasticsearch is designed like a race car. So it treats any loss of availability as a disaster, so it stops like ingesting logs, right, and delays them. And usually the solution to overcome most of these problems is to scale it up. So for stability, we often trade off cost. So cost becomes a secondary concern when you're running Elasticsearch. Further, just like a race car, Elasticsearch needs a lot of babysitting and needs a lot of sustained investment to keep it healthy, up and running. Finally, scaling Elasticsearch is not trivial. It's very hard, and you need to know what adding more capacity does to the cluster, and you need to do it in a very diligent fashion. So it is very usually a hard problem. So, but what we want instead is something like a regular car, you know? At our scale, if one node is down and you can't ingest like 0.01% of my logs, it's okay. It's an inconvenience. Yes, there is this one case where I cannot find that one log that one machine produced for the next 5 minutes, but it's not the end of the world, you know? And cost controls are extremely important in this space because your log search system does not produce any revenue for the company, so it's a cost center. Spending more and more money on it is not gonna be good for the bottom line. Further, we do not want to do a sustained level of investment into these systems. We just want a sporadic investment into the system. And we want the system to adapt to the conditions. Finally, we want a straightforward scalability story for our log search platform, as opposed to a convoluted one, which actually needs expert intuition to run these systems. So let's look at CalyDB. So we started, we had these goals, and we translated all these like abstract ideas into a few goals. So one of the things we actually did with Elasticsearch, with our system, is we wanted tired availability. What does that mean? So let's say if a log is produced, we want it to be searched within under a minute of generation end to end. In case we miss that window due to a failure or whatever reason, we want the older logs to be available under 5 minutes. Why is that important? Why do we want to prioritize fresh logs over older logs? The reason is this. You see the table here, you can see that a majority of my queries for the last 1 hour, like 93% almost, are for the last 1 hour. So if you are, let's say, behind by 4 hours, very likely the log that you ingested is probably not going to be queried ever. So spending time ingesting older data when you are not having fresh data is actually problematic. This is why we want to do tired availability. The other problem we want to solve is friction-free migration, friction-free ingestion. What does this mean? So if we get log spikes, we want to ingest the existing capacity of the logs without lagging. And we want to do this by enforcing quotas and rate limits and so on, and features like that. The other thing we want to do with ingestion is we do not want we do not want dropped logs because of field conflicts. So that's the other problem we want to solve. Further, we want to have a higher ingest rate than what is currently possible with Elasticsearch, so we can actually ingest more of our data. We obviously want longer retention. So instead of current 7 days, we might want something like 30 days. We also would like to have reduced total cost of ownership. It kind of has two components to it. One is developer time, and the developer time consists of the amount of time our team spends managing log search, and also the amount of time the developers spend trying to use the log search system. We want to minimize that too. And further, obviously, we want to reduce the infrastructure cost of the system. So the architecture of CalyDB looks something like this. Just like before, you have an application whose logs are gathered by Neuron, and those logs are written to Kafka, right? The first component in CalyDB is the preprocessor. The preprocessor does three things. It formats the logs, enforces quotas, and routes the data to a specific Kafka partition. From this Kafka partition, the indexer takes over. It indexes the data into a Lucene indexer. Periodically, it snapshots the data into a deep store like S3, and it can also serve live queries against the data it indexed. The cache node is another component in our system, which downloads the data from S3, the older data from S3, and then it can serve reads against that data. Finally, the query service is our client-facing component, which actually handles all the client queries. It gets all the client queries, performs scatter-gather queries from the indexers and the cache nodes, and responds to the client queries. And the final component in our architecture is the cluster manager. It is the brain of our system. It uses Zookeeper to persist the data to a data store, and it also uses Zookeeper as a notification store. A cluster manager basically has three jobs. It does snapshot management, which basically means once an indexer publishes a snapshot, it assigns them to the cache node. The other thing it does is data lifecycle management. It basically means that once the data reaches its retention, let's say 7 days, it unloads that data from the cache nodes and then deletes that data from S3. The final thing that the cluster manager also does is node management, which is whenever a new node joins or leaves the cluster, it basically makes sure that the work assigned to that is handed off to someone else, or if the node is free, it gets some work to do, and also ensures that the node is actually doing the work. So overall, this is the disaggregated storage architecture that CalyDB implements. It provides some standard features like separates compute from the storage. It also provides separates durability of data from storage. What does that mean? So the durability of unindexed data is maintained by Kafka, and the durability of the data that is indexed is maintained by S3. The system itself is not responsible for, it is responsible for ensuring that all the data that is produced is indexed and is searchable and is available, but it's not responsible for ensuring the durability of the data. For example, if you turn off all the nodes in CalyDB, the data is still there. You don't have data loss. You have other problems, but not data loss. The other thing with CalyDB is it's horizontally scalable. Currently, we deploy it and run it on Kubernetes. And it has minimal dependency on components. So a node coming or going does not affect the other components in the cluster or their performance. So let's zoom in on that durability a little bit as part of the recovery feature in CalyDB, right? So as I said before, the indexer does three things. Indexer takes the data from Kafka and indexes into a Lucene index, right? It periodically snapshots the data into a deep store and it serves queries. And while doing this, it is actually using the Kafka partition as a write-ahead log. What does that mean? Let's say you have the Kafka partition. It has messages 1 through 100. And you have the indexer. And the indexer is index 1 message. Let's say, boom, like the indexer is gone for whatever reason, right? So a new indexer takes its place, right? And it realizes, hey, I'm 2 behind. I cannot catch up, right? So what does it do? It actually creates what is called a recovery task that says that, hey, I cannot index messages from the Kafka partition 1 through 99. So I'm going to create a recovery task. Here it is, cluster manager, and then I'm going to start indexing at 100. This is how CalyDB prioritizes indexing fresh logs over older logs. So what happens to the recovery task? The cluster manager brings in a new indexer called a recovery indexer. What does the recovery indexer do? The recovery indexer is same as the existing indexer. It indexes the logs from Kafka and then uploads them to S3, but with one crucial difference. The indexer only has a single thread, which is enough for handling all the ingestion needs. But the recovery indexer is multi-threaded. It can actually ingest the data 10 times faster than the indexer. So it can actually catch up about an hour worth of data in under 5 minutes. So this is how a recovery index, so what the recovery indexer does is it picks up the recovery task, indexes the data, uploads it to S3, very simple. So one of the key things about this architecture that is actually good is when we are behind, we are actually adding additional capacity to the system to catch up, as opposed to taking capacity from the existing system, which is a very important property. And CalyDB uses the same mechanisms when we have log spikes. When we have log spikes, we can create recovery tasks and then recover from that. So let's talk about another feature of CalyDB, multi-tenancy. So currently, what we do is we have about 100 Elasticsearch clusters. Why do we have them? One reason is we have production, dev, and then like multiple like AZs and all of that, multiple regions and all of that. That's one reason. But the other reason is generally co-locating a very large log search customer with a smaller log search customer is actually an anti-pattern. The reason for this is follows. Let's say you co-locate a large customer and a small customer on the same cluster. And let's say either the log search customer is the larger customer is producing a lot of logs, writes, or they're doing a lot of reads because they're an incident or something. In both of these cases, the smaller customer is affected. To actually prevent this from happening, you give the smaller customers their own cluster and isolate the larger customers, and so on. You can do this across multiple customers, and you'll end up with multiple clusters, right? But while this is good for the customers, it actually creates a lot of overhead for the team managing these clusters, right? And this is why we have to build that meta management layer. So what we're going to do is in CalyDB is we want to kind of solve that problem by providing built-in multi-tenancy. So what does multi-tenancy mean? So what the separate clusters are providing is they're providing us this isolation between data for different services without running a separate cluster. So how are we going to do it? Let's say you have two services, a yellow service and an orange service, right? A preprocessor takes these logs and we allocate specific partitions to specific services. So it writes the yellow blocks to Kafka partition 1 and the orange blocks to Kafka partition 2. And the indexer, because it's tied to a Kafka partition, indexes like the data. So indexer 1 gets the yellow service logs, indexer 2 gets the orange service logs. And finally, and when you get a query for the yellow service, they only hit the indexer 1, and when you get queries for indexer 2, orange service, they only hit indexer 2. This is how CalyDB achieves multi-tenancy. Finally, this is how we achieve horizontal scaling in CalyDB. Each assigned indexer has a fixed ingest capacity. So the number of indexers we bring up is we take the total ingestion capacity we are going to have, and then we divide that by the capacity by each indexer. That's the number of indexes we have. And similarly, to determine the number of cache nodes, we get the number of snapshots, divide that by slots per cache node, and then that's the number of cache nodes. And depending on the read volume, the CPU and memory allocation is allocated to these nodes. Finally, a few more features of CalyDB. The way we handle field conflicts in CalyDB is for the known fields, you can set the types of the data that is being ingested. And for the unknown fields, we currently index them as a string. This is not optimal, so we are actually looking at other approaches to do this, but this is the system for now. And in addition, because we control our own Lucene, we can actually do additional lower level optimizations in Lucene that make more sense for log search, but not for other Elasticsearch use cases. For example, we sort all the logs by timestamp. We also have additional parallel search capabilities in our Lucene implementation. We also have a feature called on-demand snapshot hydration, wherein on the cache tier, we only keep 1 day worth of snapshots. Because as you can see from like if you remember the table before, almost like 99.8% of our queries are for last 1 data. So this helps us handle all the 99.8 queries, 99.8% of queries. For 0.2% of queries that we cannot handle, only when a user requests the logs, we restore those chunks, and then we query those logs. The advantage of this is you can actually cut down the cost of your system by quite a bit. So we also apply lightweight standardization on our logs on ingest. So we convert all our logs to a standardized format called a span event format. One of the features, there are several features that I'm not going to go into in this talk, but one of the features is we add a service name. One of the common problems in our logs is, in Elasticsearch, you map a service name to some magic index pattern. While this is good, a lot of people during an incident who are not familiar with your service do not know what that service pattern is, and it's kind of hard to find the logs. So one of the things we do on ingestion is for every log that we ingest, we actually add a service name tag. That way, people can actually just use the service name tag to find the logs for the right service. And finally, in summary, the current status of CalyDB is we are building it as an open source project in the open. Currently, our CalyDB cluster handles the largest Elasticsearch cluster we run at Slack, which ingests at about 700 Mbps peak ingest capacity. We currently can create recovery tasks and handle them to handle log spikes. We have very low operational overhead. It's already deployed on Kubernetes, and we have replaced the entire cluster several times since without human intervention. We handle field conflicts automatically. This cluster manages about 300 terabytes of data. We have a bigger cluster coming up. We ingest about 4 million messages per second, and that's the peak ingest capacity of 700 Mbps right now. And in future, we are going to do a beta release later in this year for everyone to use. Currently, the query API is a basic API for the Kibana front page. But in future, we want to add richer aggregations and also provide a Kibana compatible API so our users do not see any difference between this system and the existing system. Further, we actually want to do more performance and stability improvements as we go forward. We also have a big vision of unifying logs and traces into the same system in the future. Our project on GitHub is slackhq/CalyDB. Please check it out. We are looking for contributors and design partners. And in summary, running Elasticsearch at scale is a challenge, so we built a disaggregated storage architecture. We built CalyDB using the disaggregated storage architecture that provides tied availability, separates computer and storage, separates durability from storage, and it runs on Kubernetes. It helps us Slack enable smart growth where we can actually, it's easy to scale this system and operate it. It takes minimum ongoing investment for us, and it prioritizes fresh logs over older logs. So during an incident, we actually know what is going on. And hopefully all of this combines into a lower total cost of operation, not just in infrastructure, but in developer time. This is the observability team at Slack. A lot of people are here. Please say hi. And thank you very much for your time and the opportunity.
Awesome. We've got time for some questions. right up front.
That was a really dense talk with a lot of information. I feel like one of the densest moments was when you said we use Zookeeper. Can you talk about making that choice in this era?
Just repeat the question.
Yeah, so the question is, why do you use Zookeeper in this era? So the thing is, you need like two things, a persistent store and a notification store. And Zookeeper is the most scalable, persistent, and metadata store that is available today outside of doing two separate systems. There are other technologies that are much harder, but Zookeeper is something we already run for Kafka, we already run for Solar. I mean, it's bad at a certain scale, but as long as, so we try to design the system not to hit those scale limits, but yeah, it's like the best choice of the worst ones, you can say.
I feel like bad at a certain scale is a good description for pretty much all technology. Any other questions? Well, we got a bunch. All right, how about the closer one, and then we'll get the one behind. Yeah. Yeah. Sorry.
Just a question. Can you query different indexers and aggregate results over different indexers?
So the question is, can you query different indexers and aggregate queries over different indexers? The answer to that is yes. The query service can actually query different indexers and then aggregate data over different indexers and provide a result. So you can actually query across services.
My question is regarding, well, your system, it seems like it's optimized for more short-term analysis. For like longer-term analysis, like at the scale of like years or something, like a year of data, months, right? What thought have you guys put into that, how you approach that with y'all's database?
Yeah, so that's a great question. So for long-term analytics, currently we say that our data warehouses is the best option. And the reason for that is kind of twofold. The first reason for that is in this system, you actually move the data and then you send computation to the data. So the data actually has to be warm to be able to query it. And that costs money. Now, for longer term data, you can definitely get the data into the same system and query it. It'll be expensive and possibly slow. With data warehouses, what they do is they just keep all the data in S3 and only download the chunks in an incremental fashion, and it's cheaper. Can you do longer term analysis? Yes, but also it depends on the scale you're talking about. If you only have 10 terabytes of data for years, it really doesn't matter which system. Like you can, yes, put this in this system. But if you have collecting 100 to 200 terabytes of data a day, and then you're trying to do like a year's worth of analysis, that's a lot of infrastructure costs that you need to think about. Like the cost benefit of how you design the system actually matters at that scale.
Thank you.
Could you explain why your primary indexer is only single-threaded as it's moving through all the data? If you've shown that in the recovery path, you can't have multiple threads to catch up, and when you're horizontally scaling, if you've shown that there are, top of the indexer with multiple threads, is there a reason why you're not doing that?
Yeah, so one of the reasons we only need a single indexing thread is Lucene is actually pretty efficient. So doing multi-threaded indexing is not needed. You only beyond, let's say 3 or 4 Mbps is when you need to start in like getting into multi-threaded things. So that's why we keep we don't need that much indexing capacity in the indexer. That's one reason. The second reason is even if you could ingest more faster, your chunk size will be pretty big. So if the blast radius of a failure is pretty high, so this helps us also limit the blast radius. And the other advantage of just having a single threaded indexer is you can actually, generally a single thread actually uses one core. So it's much more easier to plan mentally on, when you scale it up and scale it down, it's much more easier to plan how to scale the system. So there are like advantages like that operationally, and that's why we just stick with one thread. But other than that reason, there's no other reason you can do multiple threads.
Great. Were there any questions over on this side or up top? We got them all. Oh wait, no, we got some more. I'm missing it. The aisle there, yeah.
So the question is, can you talk about the cost comparison with Elastic? So we are currently, like we put this system in production, we are roughly similar in cost right now. That's because of some of the things that are more tied to our infrastructure than the implementation itself. But we are actually hoping that the system is significantly cheaper because we are not keeping older data and we only load the data on demand and things like that. We don't do all of those yet, but that's the plan in like the next few months.
I think there's one over here, right? Yeah. Oh, same question. Gotcha. Alrighty. Great. Thank you very much. Another round of applause. All right. So we are going to be breaking now for lunchtime. We will be back here at 2 o'clock to kick off the afternoon sessions. We'll see y'all then. talking up the chicken place, Mama Bird, without actually realizing that they're not even open for lunch. So I hope no one actually went over there. So if you did go over there, I'm sorry. I will make it up to you by making sure there are like 450 donuts here tomorrow for you. So and that's the other thing I want to make sure you all know. This conference is just a reason for Jason to order a lot of donuts. There will be a lot of donuts here tomorrow, so make sure to save your appetite. So all right, we're going to kick off this afternoon's session before the sponsor parties. And I'd love to see a big round of applause for Clint Sharp.
Sweet. Thank you, everybody. I'm super excited to be here. This is one of my favorite conferences. I've been here 3 times, never presented. It's a super big honor to get to be in front of all of you guys. If you have not met me, I'm Clint Sharp. I'm co-founder and CEO of Cribble. We're a sponsor. We have a booth up there, so come say hi to us. I'm here today to talk about literally a project I had to invent so they would let me keep coding. It's an open source project we're here to talk about with AppScope today. Super big problem that I think that we're solving, and we'd love to get your feedback on it and tell you a little bit about how we think the world could be a little bit different. So I'm going to say a few things that I think are not particularly controversial, and then maybe one thing that is a little bit controversial, and then we'll see. So operating a service today requires observability. And I'm sure there are people getting by without good observability, but really to operate a post-digital transformation, modern digital service, microservices, interconnections, etc. I really need to be able to ask and answer arbitrary questions of my data and be able to understand the end user's experience and how things fundamentally are secure. I think we can get a line around this. I hope so anyway. Operating a service, observing a service rather, requires high fidelity application level data. I cannot ask questions of data I do not have. And so if I want to understand my user experience or your user experience with my service, I need application level information to inform that. Hopefully high cardinality application level information that is per session, per user, to where we can dive deep into an individual user's performance and really try to understand fundamentally what's going on with that application. But also hopefully lower level information as well. Operating system level information, file accesses, network sockets open. We need a lot of information to understand truly how to observe a service in today's world. And most applications are not very observable. That may be controversial, I don't know, but in my experience, working with many of our customers and having been in this industry for a pretty long time, that the majority, infrastructure is pretty observable these days. There's a lot of out-of-the-box infrastructure metrics that tell us a little bit about what's going on with our infrastructure, but applications themselves, we're on a journey, let's call it, right? So there are some applications which are very observable. Many applications, though, are simply just not very observable at all. So how do we observe those applications today? Well, one, we have metrics. So show of hands, who has infrastructure performance metrics in their environment? That's pretty ubiquitous, right? Pretty much everybody's hand went up. CPU and IO and some network traffic and things about all the VMs that you're running and possibly the containers, etc. Generally not high cardinality, so it's really difficult to get to per, in fact, it's so not high cardinality that if you accidentally introduce a high cardinality dimension, odds are you're going to blow up your time series database and everybody's going to be screaming at you. So generally metrics are, for summary level information, running your dashboards, everybody has these, right? They're very exploratory though. So I can navigate this data, I can query it, I can learn to understand my environment. Logs, who has logging in their environment? That's pretty ubiquitous, right? I'd say 80% of the hands went up. I have some way of grepping my logs or centralizing them into Elasticsearch or Loki or one of these types of tools. So logging is pretty ubiquitous. It is high cardinality. I can generally ask very detailed questions. It may take me a while to get the answers back, but I can ask very detailed questions in my logs and get information back. Distributed tracing. How many people have deployed distributed tracing? I'd say half, a third to half, something like that. That's impressive. I think this sample set, by the way, is a little skewed. I think more broad than the typical market is, right? I would say, distributed tracing, just gut feel, 25% penetration, let's call it, right? Certainly not 70 or 80% penetration in terms of applications. This is very high cardinality. It's less exploratory. I think of products like Jaeger and others, which are like really awesome, but they're pretty on rails, right? I can navigate to a particular trace. That might be controversial. I'm sure that there are vendors here. I mean, like Honeycomb is an example. They're very exploratory. They can do tracing and dig in. So different vendors give you different experiences, but by and large, tracing is not the most exploratory sort of user experience. Also tends to be a little bit longer time to value as people go instrument their code, et cetera. And then APM. Who has APM in their environment? A little bit, about the same, half-ish more. APM I generally define as kind of the last generation, but auto-instrumented, usually more metric-centered than high cardinality, sort of span type of events. Also another way. So what we have is relatively ubiquitous coverage of infrastructure and not really ubiquitous level coverage of application data. So the question that I would ask is how can we go from a ubiquitous set of exploratory, infrastructure and logging level stuff and bring application level information up to becoming ubiquitous so that we can ask and answer these questions of modern services. So how do we make application level data ubiquitous? So we have service meshes, good-ish adoption. I mean, we're seeing a reasonable amount of service meshes in the world. I tend not to see, this may be controversial or not, but I tend not to see them deployed simply for observability. They're generally being deployed for mutual TLS or service discovery or other reasons for solving the service mesh problem, and then I get some observability, as a result of deploying that service mesh, but not generally the leading reason for that. eBPF coming along incredibly nicely. We saw from Splunk, the Xflowmill guys yesterday, great presentation. The Pixie Lab folks will be here tomorrow as well. Really excited to see that presentation. Their work looks really amazing. It's coming along really well. I think limited support for encrypted streams, harder with dynamic languages in eBPF. There's some pluses and minuses, right? Like Python, Node, these are harder languages to instrument in eBPF, but we're making a lot of progress. And eBPF may be the path to solving ubiquitous application level instrumentation. I could be a believer that is. But we here at Cribble and the authors of the Scope project really felt like there was another mechanism that we could use to gather application level information ubiquitously, and that's interposition. And so interposition is runtime agnostic. We're interposing a shared library between the application and the things that it's requesting. Things like TLS transactions or things like opening network sockets or opening files. That means we can do a black box instrumentation of nearly any binary, C, Rust, Go, static binaries, dynamic binaries. We can instrument nearly anything, and we can get to full payload, including TLS type of transactions. So we call this project AppScope. I'll give you guys URLs later. It's all Apache 2 licensed. You can go grab the bits. It emits APM-like data as metrics and events in open formats. So this is dog_stats_d format. This is TCP JSON, so just JSON documents, new line delimited on a TCP port. Very easy for anybody to go consume this. I've used, for example, things like FluentD or FluentBit to consume this information, or Telegraph to consume this information. You can also send this information to our commercial products. And we can scope any Linux binary simply by prepending this command scope. Immediately we'll start to see robust application behavior. We also collect application log information as sort of a side benefit. We also see all the log files that are being written and the data that's being written to those log files. And it provides the observability that you would tend to get from like a service mesh without having to deploy a sidecar, without having to deploy anything else that you're actually managing. So picture-wise, the application loads a shared library called libscope. That sits in between all of the system calls, all of the crypto libraries. That's what allows us to get to clear text payload, even on encrypted transactions. It's language agnostic. It works with anything, like I said. Very, very lightweight. And again, outputs data in open formats. So you're probably familiar with a lot of different kind of instrumentation mechanisms of getting data black box out of applications. One would be an example of strace, right? Probably everybody's used strace over the course of their career. Super detailed information. Sometimes it's the only thing that you've got in order to try to understand what this application is doing. Tends to be very verbose, very hard to read, but it's awesome because it works with just about anything, right? I can run strace on just about any binary. We're sort of like that in that we're seeing system calls like strace is. We're sort of like TCP-dump because we're seeing wire data. But we're seeing wired data, including clear text payloads, even if the application has encrypted it. And it's sort of like a man-in-the-middle proxy because we actually understand protocol. So we understand HTTP, and we can see HTTP and HTTP2 level events. And so we can understand kind of what that application is doing. Okay, with that being said, let's actually show real product. Woo, all right. Always happy that worked. It's on the network, so we'll see how it goes. So right now what I'm showing you is I'm going to be showing you Scope, the command line experience. And so Scope has a single user experience that we can use to just interrogate any running application. It can also be deployed as an agent, which I'll show you guys in a little bit. So to start with, this is running in one of our sandboxes. You can actually run this yourself. You can go to sandbox.cribble.io and go run the AppScope Fundamentals sandbox, so you can reproduce everything that I'm doing is all reproducible completely online. So to start with, I'm going to send it. I lied. There we go. All right. High latency. Well, you know, it is live. All right, so we'll try, and we'll just hope that I can type well. Unfortunately, it is over the internet. Look at that. Let's see what my latency looks like. Ooh, yeah. All right, well, if you're on the speaker Wi-Fi, if you wouldn't mind getting off. All right. JK. All right, we'll see if that comes back later, and if not, then we'll try to make do what we're having. So I'll show you the output of the agent side deployment, and then hopefully latency will come down enough that I can actually do live demo, which I was working just fine about before all you guys came back, actually. Amazing how that worked out. Okay, so we are sending data from AppScope over to Elasticsearch and Prometheus. AppScope outputs metric data. It can output that in dog.statsd format. You can send that data to CribbleStream, which is our commercial product. In this case, CribbleStream is receiving that data, translating that data to Prometheus Remote Write, and translating that data to Elasticsearch's bulk ingestion API. And we're taking all of the data that's coming out of AppScope today, which hopefully we'll be able to show you interactively in a minute, and sending that data to both Grafana and to Elasticsearch. And so as we start to look at the data in Grafana and we start to look at the data in Elasticsearch, we can see pretty detailed information about what's going on with these applications. In this case, I have deployed Scope in Kubernetes as a mutating emission webhook, and so we're seeing all new containers that are being started. We're automatically instrumenting each new container with a Scope binary, so we're seeing all the activity from what's going on inside of that particular container. In this case, we're actually scoping an environment that has Elasticsearch in it, it has Cribble in it, it has Prometheus in it, and we're seeing metrics actually from Prometheus, from Elasticsearch, from Grafana. We're actually instrumenting, it's somewhat meta, in that we're actually instrumenting the applications that we're sending data to, sort of full, not a really good term for that, but anyway, kind of full circle there. And so we're seeing HTTP level requests. I can see that curl is requesting data from Elasticsearch. I can see Elasticsearch receiving HTTP requests on the Java process. I can see Kibana, their node process. I can see the Prometheus Go process. And we're seeing the number of HTTP requests that are going on in that environment. I can also see that there are a number of errors that are happening in this environment. I have kind of a built-in troubleshooting use case in this, but I probably don't have time on stage to walk all the way through each one of the finding the actual real problem. We're showing client bytes, we're showing server bytes, we're showing how much network data is being transmitted, we're showing how much CPU is being consumed by each process, so you can see each process that's being started is getting its own time series for performance of CPU and I/O. File opens, file closes, file reads, and file writes. So this is metric level information, and so that's generally summary level information that we're outputting. You can send it to any TSDB and work with it interactively, whether that's Prometheus or Mimir, or whether you're sending that to Splunk or SignalFx or Datadog. Pretty much any time series database can receive this type of instrumentation. But we're also outputting high fidelity event level information as well. So in this particular chart, I'm looking at the number of requests going to Elasticsearch, going to our API server, going to Kibana, and you can see this is split by URI. So I'm showing you in detail, these different user endpoints. I'm seeing the Elastic bulk ingestion API where data is being posted to. I can see, data being written to Prometheus on the API v1 write endpoint. So we're grabbing this information out of unmodified Linux binaries, all completely in user land. So this has no kernel level interaction. This is all done, completely on the user land side. And we're seeing high fidelity application level information. We can actually get to up to and including full payload. So we can see and parse payloads and understand in detail kind of what's coming in and out of that HTTP based application. You can see kind of the most popular endpoints that we're collecting here, the bulk endpoint, the Prometheus endpoint. You can see us kind of sending the data in the environment and kind of bootstrapping that ourselves. So I don't know if maybe I've gotten a little bit lower latency. I have not. Cool. So I have a really cool interactive demo showing you how to scope everything from Python to Perl to, you know, any sort of unmodified C binary. Unfortunately, latency is too high, and so I'm just going to have to wave off on that. It's probably just not going to work, even though it was working fine. Oh, wait. What? Yeah. Okay. We're just going to skip it. All right. So I'm going to wrap up my presentation early. With that, let's talk a little bit about what we can do with this type of information. So with ubiquitous application level information, the problem that we're immediately going to create is like, well, it wasn't like you didn't already have enough metrics or enough logs or enough, you know, whatever. So how do we actually deal with, you know, the upcoming deluge of data that having ubiquitous application level information is going to give us? As an industry, we think there's a number of places we can go with this. One is, obviously the data can go to your existing metrics and log solutions. So you can take kind of ubiquitous application level information, send it to Datadog, you know, send it to Prometheus, send it to Elasticsearch, send it to Splunk, send it to wherever, you know, your tool of choice happens to be. You know, AppScope is emitting this in open wire format so that you can, you know, send it anywhere you would like. We don't feel like you have to send it to Cribble. We're donating this to the industry. We want everybody to be able to make maximal use out of it. Although it's going to be, you know, what amounts to a metric shit ton of data, right? Like you're going to be struggling dealing with kind of this amount of information. And so there's a couple of newer approaches that we are pioneering at Cribble that we think are going to help us deal with the massive deluge of data and be able to process significantly higher multiple amounts of data than we can process today. The first would be edge persistence. And so we are starting to roll out a product that allows you to persist circular buffers of high fidelity data at its origination point and federate searches to potentially tens to hundreds of thousands of endpoints in order to give you access to this level of high fidelity information. Free capacity at the edge is being used for doing that data processing. And if you look at kind of, Datadog did a survey in like 2020, the average utilization of a Kubernetes cluster CPU-wise is sub 30%. So there are a lot of spare CPU cycles sitting out there on nodes not being utilized today that can be used for observability and telemetry data processing. And so we think that this is a really interesting, you know, sort of new architecture that we're looking to pioneer. And the last additional thing that we're talking about is this concept of an observability lake. And observability lakes are a little bit different than just kind of your standard data lake. Obviously, it is a data lake, but observability lakes have data in open formats, but also have a wide variety of data. So start to think about, we can start to persist things like configuration data, or things like full wire data, or full payload capture data that may end up in the observability lake that gives us the opportunity to go back in time and understand what may have been happening with that application. Dating back to about a decade ago, when I was before I was a vendor and I was a practitioner, you know, one of the things that was I wished I would have had, like every time the application crashed, I wish I could have had a time scrubber to go back in time and see all those payloads. Just if I would have had an hour's worth of payloads, I knew within an hour that that application was having a problem, and I could have decided to egress that hour's worth of payloads, and what I wouldn't have given to know what actual request was made that ended up creating that error. And today we don't really have access to that level of payload information. It's too difficult to egress that level of information, and we think that there's a future whereby which we can have access to full payload information for future troubleshooting and diagnostics. And then we can also replay that data to other solutions at a later time. So the lake can also be like a really nice place where we're just stashing, you know, massive quantities of observability type of data, and you may not analyze it in place, you may analyze it in place, or you may end up moving that data to something that is a more appropriate sort of analysis solution for that data. So with that, and I think my demo's sort of busted, but happy to show people more. I should have had a more local copy. It was actually working, but we'll be at the booth if anybody wants to come by and see kind of interactive.
You want to flip to the guest network.
Oh yeah? Okay.
As crazy as that sounds.
Let's try. Let's see what happens. No, there should have been more food. Guest, all right, let's see. Who knows?
Got to give a round of applause for a live demo here. We're doing it live.
There we go. Hey, what do you know? All right. All right. Hey, you want to see a demo? All right, let's do it. All right, cool. All right. So first thing I'm going to scope is just bin echo. Bin echo is a ludicrously simple utility. And so now I'm going to run scope metrics, and you can see a little bit of detail about what we're collecting, right? We're collecting that a process was started, it consumed this many microseconds of CPU, there was this many kilobytes of RAM consumed, this many threads created, this many file descriptors created, this many files opened, etc. And we also keep track of events. So we can say, look, there was a console message true printed for that particular command. So now what I'm going to do, I'm going to scope something a little bit more old. And I'm going to dial it up to 11. If there's any Spinal Tap fans, we'll put verbosity up to 11. And what I'm going to run is I'm going to run Perl, and I'm going to say, let's print Monitorama. Cool. I misspelled it. Probably still misspelled it. Now if I look at metrics, we're capturing even more detailed metrics. So we're keeping track of all the different files that it's tried to open. We can see that it's trying to open a number of files and actually erroring, attempting. I don't know what Perl is doing. I haven't used Perl in a very long time, but it's interesting to see what it does. We can see how much CPU it consumed, how many file descriptors it opened. And if I look at scope events, we actually see that it opens up urandom and dev null. I don't know what it does this with every execution of Perl. I don't know what it's doing with dev null, but maybe it just likes to have a copy of that written there. We can also pick up log information, which I think is super cool, because applications write log data everywhere. And oftentimes I don't even know where that application is writing logs to, and I actually have to know that it's being written somewhere, fundamentally on the file system. So if I look at this simple little log script here, I'm opening two files. One, I'm opening a text file, and so we're not going to pick up the contents of data being written to an arbitrary text file, but we have a simple heuristic that if it has log in the path or it has log in the name, we'll automatically pick up file writes that are being written to log files. And so now I'm going to scope Python 3, and I'm just going to run log py. And if I look at scope events, cool, I can see that I did indeed log will see this string to this particular file. So this is pretty cool. So like in a couple of minutes, we have scoped a C application, we have scoped Perl, we have scoped Python, and we've gotten reasonably interesting information. So one of the things I'm going to run in the background is I'm going to scope Nginx. And then over here, I'm just going to start another terminal here. I'm going to say while true, let's do curl HTTP localhost, and let's sleep 1, and then let's done. Oh. Might just help if I spell localhost right. Okay, so now I'm running curl in the background, just kind of on a loop. We're just going to go request some information. We're going to see what comes out of that. And so if I scope manually over here, I'm going to scope curl. And this time I'm going to choose HTTPS because I want to prove that I can actually look at encrypted data that's on the wire. And I forgot here, I'm actually going to ignore that it's an invalid certificate. Cool. And so if I go look at scope events now, you can see that there's an HTTP request made to localhost. You can see that there is a response. So let me go look in detail at what this response is. So I'm going to go scope events. Whoops. Ah, shoot. Nope, not that. Events. There we go. Oh, shoot. That was right there. Nope. One more. There we go. And so I can see in detail what HTTP level protocol information we have captured. We've captured that it's an HTTP 1.1 request. We requested that it's a GET. We can see that it was done over HTTPS. We can see what user agent was captured. And fundamentally, all this data is just JSON data. So we can egress this data to anywhere. And in my example where I showed you Elasticsearch first, this is the class of information that we're sending out there. So one thing I'm going to do is I'm actually going to capture payload information as well. So I'm going to do scope run -p, and I'm going to say curl HTTPS localhost. Oh, forgot -k. All right, so now if I look at, again, I'm going to run scope flows. So we also keep track of the network flows that each application is making, how many TCP connections or UDP related information that we have, how many bytes are going over that. And if I want to see like what was sent out over that, oh, whoops, flows and this guy. I'll show you that the GET request was made, and again, this is over TLS. So I use this shit all the time because I can't figure out what my own application is doing, and all I really want to be able to get to is just like what HTTP request was made, what was actually on the wire, what was coming back. Oftentimes I find myself going into my application and writing logs for this, and post-scope I find myself just running scope on that application and seeing what's coming out over the wire and seeing what's coming back and making it really, really trivially simple to see, kind of the output of what's being sent out on that connection and then what's being sent back in on that connection. So we're seeing full kind of payload, wire data that's in there. So I was going to show you all this first and then show you the examples of how that all gets consumed. We kind of did that in reverse, but it's good. Thanks to Pete for helping me find a Wi-Fi that was working. And so just covering up on next steps, I think we may have a little bit of time for Q&A or I may be over. If you think this is interesting, stars on GitHub, please. It's a really cheap call to action, but we'd love your stars. I think we're not that high in stars. We haven't really promoted this much. This is kind of the first time that we've come out to talk about this product and this project. This product has been in development for about 3 years. It's battle tested. It runs on the inside of our cloud. It's guaranteed to cause weird problems in your environment. Please go test it. make sure you run it in a lower environment first before you promote it to production, because like it'll probably work fine, but you know, like I would test that stuff first before you go kind of rolling this out full and on in production. Anytime you're doing any kind of low-level instrumentation, my strong recommendation would be like test this in lower environments first, but we'd love if you would just go stars on GitHub to start with. We have online sandboxes at sandbox.cribble.io. Everything that I was doing in that sandbox there's actually an interactive tutorial with documentation that will walk you through exactly the same steps I was just taking with that same demo. So you can actually go just try it yourself. You can also download the binary from appscope.dev. You can also grab the same Kubernetes demo that I did, is also hosted out in our GitHub. If you think this project is interesting, we're hiring a product manager for this product, so please come see me. We would love to hire you. And then we're also a commercial company. We've got a lot of products to sell, and so we've got a booth out there. And if you think that any of this stuff sounds interesting, we'd love to talk to you up at our booth. And so that is it. And I think, do we have time for Q&A?
We sure do.
All right.
Awesome. Do we have any questions? Got one right
Yes.
here.
Any roadmap to do like APM and try to understand internal functions, you know, or common libraries? Since you're preload, you could, in theory, get in front of common libraries, you know, to do up above syscall level instrumentation.
Yeah, so the question was, any plans to move into APM and give kind of function level, you know, et cetera? I think there's a couple of areas of collaboration in open source land here, right? So one is that I think there's some really good potential collaboration between us and a number of the eBPF related projects in order to use us as the user land component rather than trying to get at everything from kernel space and try to get into user space. Use our user land and use eBPF to push our instrumentation into user land. And I think there's also other collaboration points where we may look to, for example, the OpenTelemetry project, who already has some pretty good auto instrumentation. I don't think that we would look to go build the auto instrumentation ourselves. I think there's a variety of projects out there that are attempting to do auto instrumentation. And then one of the problems with them doing auto instrumentation is then it's oftentimes difficult for them to get themselves into, for example, Node.js and to kind of jam themselves in. And I think we could probably use AppScope where we're sitting. We do a light amount of bytecode instrumentation today, by the way, in order to get to clear text payloads of Java applications. So Java has its own TLS implementation, and so we have a minor amount of Java bytecode that allows us to get inside there. But I don't think we would likely build that, but I would love to collaborate with other projects that already have that information in order to use us to make it more easy to get that into those areas. It's a great question, though.
Got one right over here.
Yeah.
So you mentioned Java and bytecode, you do some bytecode research to get content traffic. How about Go apps, where everything's statically compiled and your system calls just have the encrypted data on the wire?
Yes, the question is, what about Go apps? Back to my demo here. So if you look at, for example, scope, if I bat HTTPS Go here. So this is a super simple Go application that's making an HTTP request to my Nginx web server that's here. If I look here on my file system, it's called Go HTTPS. So just to prove that this runs, scope run Go HTTPS. Okay, so it picks up the same payload, and if I go look at scope events, we can see that indeed we are instrumenting Go HTTPS. So we do support Go. Go is really difficult to do, and if that is of interest to you and you like to talk about low-level language runtimes and how weird Go is about all of its internals, I've got a couple of developers who will talk their head off for hours about how they ended up getting that done. But we work with any statically linked binary or any dynamically linked binary.
I see one right here.
Yes, hello. Yes, the question is how we measure the performance overhead. We quoted at about 2%. And so yes, we have. That being said, you can tell from its 100 and something GitHub stars, it is not ubiquitously deployed. So I'm certain that there are edge cases there where we're not going to meet that SLA. But in general, from our, we have a robust unit and integration testing environment that tests this actually against the majority of the Linux user land as we're running through our test set. And so we know it not to crash in most places, and we know its overhead to be low. That being said, it is version 1.1 instrumentation software, so take that with a grain of salt.
We've got one up top here.
Yeah.
Yeah. So I see you have native support for HTTP. You understand HTTP. Do you understand something like gRPC or other protocols?
Yeah. So the question is, do you natively understand gRPC or other protocols? gRPC is really, really difficult to man in the middle. And this thanks to the protobuf guys for building a wire format that doesn't self-describe. Like, you have to have the schemas on both sides. So the answer is, can we eventually do it? Yes, we do not today. It's something that's definitely of interest to us. but it is not built. I don't think it would necessarily be hard. The place where I might move that intelligence, we also have the ability to egress full payloads through our wire protocol to other analyzers as well. And so the right place to do that might not be in the library itself, but might be in a third party that's receiving that payload and figuring out how to do the decoding of that information.
All right, I think there was a follow-up question here.
Yes. One more, and there's one more over there as well. Yes.
Related to the load question, for someone that's got a CDN type payload where they might be doing 40 plus gigs on a machine, obviously Cribble Stream could sample later.
Yep.
Is there any sort of source sampling to avoid some of the, either to only look at so many of the syscalls or the connections, or would you just suggest then, are there any built-in sampling or other sort of, be lower overhead for really high volume workloads?
Yeah, so the question is, for very high workloads, can we sample or another way dial back the instrumentation such that we're not, we would be able to lower performance overhead? We do some of this on our own in terms of like all the data that's being moved between the application library and then the central process. There's a bunch of ring buffers and so if those overflow, we'll miss samples. And so like we will default to data loss rather than breaking your application, as an example, right? So there's we can have a lot of discussion about the internal design about how data moves through the library. We may be able to do some of that. I would have to get back to you. I'm not 100% sure. And if we don't, we probably should. And it's a pretty good idea. And there was one more question over there.
We'll do this last question here.
Will it work on BSD?
Will it work on BSD? I haven't run BSD in so long. Right now I'm going to say it's Linux only. The approach, in theory, should work on BSD.
I mean, it's open source. You just clone it.
Sure, yeah.
Clone and build it, right?
I'll tell you what. Why don't you try it, and then you let me know. You'll let me know. That'll be great.
Awesome, great. Thank you so much. This is a fantastic talk.
Thanks, everybody.
Yeah, I don't know which speaker out here is crushing the speaker network, but the guests, you're all great. Guest network's amazing. All right, we've got a slew of sponsors. We're going to call this Key Competitor Row here, as that's the joke that they actually made while sitting in the back here. We've got New Relic, Splunk, and Instana. We're going to kick it off with New Relic.
Really competitive lineup here. All of them are competition.
They wanted to actually all come out together and just like battle royale. Way to stop it. Oh, man. I mean, let's be honest, everyone here is a competitor. Like, come on.
It makes it more spicy, I like it.
Don't touch it. All right.
Okay. Sure.
All right.
Can I touch my computer? I'm joking. Yeah.
Yeah.
Hi, everyone. My name is Daniel. I work for New Relic. And yeah, I'm super happy to be here in Monitorama because I think this is the first conference where I don't have to explain observability to everyone here, which is amazing. Like, that is one of the things that I kind of dread at conferences because I still don't understand exactly what observability means. But anyways, so yeah, I'm here to talk about OpenTelemetry. Has anyone heard of OpenTelemetry? I'm assuming all of you have because you're here. Yes, OpenTelemetry. Yeah, so today I'm here to talk about how great New Relic is at supporting OpenTelemetry in our platform and why you should send us data from your OpenTelemetry collectors. So yeah, OpenTelemetry is a great open source way to collect data from your applications and send it to a backend like New Relic to process and surface up that data. So when you have an incident or you're just trying to figure out what's going wrong, you're able to quickly figure out the root cause and fix it. And yeah, New Relic does a great job at integrating all of the data that you collect from your applications and surface up only the information that you need to fix your problem because OpenTelemetry generates a lot of data. So yeah, I'm here to kind of walk through what it would look like when you start sending us data through OpenTelemetry. So through our OTLP API endpoint, if you send us data, you're able to start triaging all of the errors that you get through OpenTelemetry through something called Errors Inbox. So if you're familiar with things like Sentry, it's kind of our answer to something like that. So when we click on a particular error like this, we're able to see the number of occurrences as well as key attributes associated with the error, a stack trace, logs, and attributes. So you're able to quickly see if there's anything that
looks weird, you're able to quickly see like, hey, here's a stack trace, here are logs that are relevant. And you're also able to assign it as a Jira issue and triage it immediately within the UI. So you can assign it to a particular person or talk about it in the built-in UI. Or you can just do what normal people do and make a Jira ticket and hopefully someone responds. And then let's click into the particular service itself. Here you're able to get all the golden signals like you would a traditional APM vendor. But where things get pretty spicy is when you want to see how your errors look like. So let's click on a particular error. You're able to visualize your distributed trace directly in New Relic, so you can quickly see the root cause of particular service issues. So the cool thing about New Relic is that you don't have to figure out, okay, does this span seem longer than usual, or is this slower than usual? Because we have ML running in the backend to help you figure out, okay, is this particular part of the application taking longer than it should be? So you don't have to make all those guessing decisions. New Relic will kind of surface all that information up for you. In addition, we have something called logs in context, where you can only see the logs that are relevant to this particular trace. So you don't have to go to Splunk or another vendor, to figure out hey, what are the logs that might be related to this particular trace? We can all surface up that for you using our platform. Awesome. So that is distributed tracing. In addition, with certain collectors, processors, you're able to relate a lot of your traces and other OpenTelemetry data with infrastructure data. So here you can see exactly if something is an infrastructure problem or a service level problem, you're able to quickly figure that out with this view. So here in the top two visualizations are infrastructure level metrics. So your memory utilization in your Kubernetes cluster as well as your CPU utilization. And if you see that spiking at the same time as a service level metric, you know that it's an infrastructure problem, so you can call someone else instead of trying to figure it out yourself. And then here you can see your service level metrics correlated, so you can quickly find a root cause of an issue to figure out if it's an infrastructure level problem or a service level problem. Anyways, that is it for infrastructure. Something else that's really cool is that OpenTelemetry is a community project, which means that certain languages and certain frameworks are a lot more mature than others, right? So things like Java and .NET are really advanced, and other languages may not be as advanced because they don't have the community support. So that's where New Relic comes in. Because we have proprietary agents for a lot of languages and frameworks, they work interoperably with OpenTelemetry. So right here, the email service, oh sorry, I got really loud. The email service is a APM agent that's instrumented with our proprietary agent, and everything else is OpenTelemetry. So New Relic is great if you're on that journey to migrating towards OpenTelemetry, but you're not ready to make that whole leap and rely on every single service to be instrumented with OpenTelemetry. New Relic's a great alternative to kind of help you with that migration journey as you transition from all the proprietary agents into OpenTelemetry. So yeah, that is my time. That's a really fast speed run of all of the things that you could do with OpenTelemetry on New Relic. Let me know if you have any questions about OpenTelemetry. I'll be outside in the New Relic booth. We're hiring. Did I hit all the points? I think so. Anyways, thank you so much. Woo.
All right, thank you. Getting really spicy backstage with the Splunk team. Who is up next is the Splunk team.
Thank you so much.
We were laughing, we brought two to the fight. So Sarah and myself.
Hi everybody. So today we are excited to share some Splunk innovations and data points from our 2022 State of Observability report with the goal of helping you build better software, troubleshoot across any environment, and deliver features and innovations to your customers faster. And by a show of hands, are any of you using Splunk today? Anyone? Yes. Cool. So yeah, I mean, we all know what Splunk is, and the point of us being here is to really introduce what we're doing in observability and our flavor of it. So I'm Sarah Ware. I'm a specialist in digital experience monitoring. I'm a former customer, which means that I'm personally more invested in geeking out about problem solving. And I'm also a, thank you, also a former QA manager, which is why my shirt says looking for trouble.
Awesome, and good afternoon, I'm Derek Dykins. I sit within our industry advisory team. I'm our global retail industry advisor, so I get the pleasure of working with our largest retail, quick service restaurant, and hospitality customers.
So we're kind of preaching to the choir here, but here's some pretty numbers to give context about why Splunk was driven to better help our customers by growing in the observability space. You know, you guys know that software is the foundation for how organizations interact with customers, manage supply chain, and measure and benchmark against competitors. And since 2020, we've seen a 70% increase in internet usage, 76% increase in e-commerce, and 65% of customer interactions are now digital, which is super crazy.
Yeah, so we wanted to take just a quick step back to understand the why and what behind observability. And sitting through some of the sessions, I think talking to a lot of you just at the Splunk booth, it's been great to meet with the attendees and get all of your diverse perspectives on what observability means to you and really what your strategy is going forward. So I think a lot of folks are getting used to this term of observability. When I meet with a retail leader, a CIO, a CDO, they're like, hey, help me understand observability. What does that mean? You know, they're hearing a lot about it. And so we look at it as observable events, whether it's structured or unstructured data. You know, being part of the Splunk platform, we now look at logs, metrics, traces, and synthetics all coming together in a meaningful way so that we can provide really these large corporations, small startups with end-to-end visibility across their most business-critical applications, as well as any of their business flows. So just sharing kind of some more statistics around observability. Again, coming from the report that we just released earlier this year, really observability is meant to give our customers more confidence as they build more resilient systems, as they reduce alert fatigue and all of the different types of swivel chair troubleshooting that we look at, but also help teams be more collaborative and productive, as well as proactive. So a lot of the customers that I'm working with, we're creating roadmaps to not only proactive monitoring, but predictive, where we do things with machine learning, as well as put together an AI ops strategy for them. So when we look at just the numbers, again, mature observability teams can cut down costs by 90%. When they eliminate the swivel chair troubleshooting methodologies, observability leaders also reported a 69% improved MTTR for unplanned downtime. And leaders are 2 times more likely to detect problems in minutes versus hours, or in the world of retail, sometimes it can go days before something's reported at the stores.
So if you weren't convinced about observability yet, hopefully now you are.
Yeah, so hopefully those numbers are helpful in your day-to-day conversations back at your companies. And so really, when we look at the new approach, there's a few different things that are different than if we were to look back across the last 5 years. The first one is really knowing where to look and who to engage. So we're really trying to get rid of the war rooms of 30, 40 people, kind of calling everyone in the middle of the night, really understanding what that root cause is and pulling the right folks in with the right data at their fingertips to quickly solve and resolve that issue, but also be able to have full control of your data. So we've heard a lot about open telemetry, Splunk being a big contributor to open telemetry. We do feel that this makes a lot of sense with our new approach. All right, so with that, I'm gonna pass it to Sarah.
Yeah, so we only have about a minute left. So these are, our Splunk principles for observability, end-to-end visibility, full fidelity, and AI-directed troubleshooting. And like Joy mentioned earlier, throughout all of this, working on both useful visualizations for us humans, as well as how that machine learning can really help us out. And we have, a ton of customer stories about success. For example, Rappi focusing on app performance and SLIs, and being able to troubleshoot and solve issues while they're still deploying to their customers.
Yeah, and another example would be IKEA. So they have 5 global data centers around the world, 25,000 servers across their data centers, their store environments, and distribution centers. They actually process 300 million transactions a day, so that ends up being about 13 transactions at checkout per second. So as you can imagine, even just losing a few minutes of time worth of transactions, I mean, we're already talking tens of thousands of dollars whether that be the payment goes down, a price lookup at checkout, the actual terminal goes down. So really understanding kind of the overall value of observability is key as you put these projects forward. And then we'll just kind of cut to a quick thank you, and we have a QR code here for our happy hour tonight at the University Club. So think of Splunk as an advisor in this space. We love to collaborate with our customers and really figure out kind of best-in-class, purpose-driven solutions for you as you take on the observability charter. So hope to see you tonight. Stop by our booth as well. We're still upstairs.
Thanks, guys.
Thank you.
Awesome, thank you. All right, and our last sponsor before, if I can read anything here, before our next talk, before our break, just key point, pour-overs are unfortunately no longer happening just for today, I believe. You'll have to get your caffeine fix for tomorrow, but that's fine because you're gonna have a bunch of donuts to eat with the coffee. So, all right, let's give a hand for Instana.
Hi everybody, save the best for last, right? My name's Josh Lee, I'm the developer advocate at Instana, an IBM company as of 2020. Instana is a cloud-native enterprise observability platform. It's a lot of buzzwords, so what does that actually mean? Well, at Instana, we believe that true observability requires complete coverage with zero gaps, whether it's a legacy application or serverless. And in order to achieve that, we believe in automating as much as possible. For us, that starts with a one-liner installation. You install the agent on each of your hosts. We also only charge per host, so your pricing is very predictable. And from there, the agent is going to reach out and automatically discover any of the 250 plus supported technologies that are running on your services. This is an example environment that we use. We have an application called Robot Shop. It's a simple e-commerce microservices application. It's running inside this Kubernetes zone called Kate's demo. This is a map of the entire infrastructure that is reporting back to this specific Instana tenant. We can hover over any of these hosts and see an overview of the containers and the processes running on these nodes. And we can also zoom in and drill down into a specific service if we want to. So here we can see we have a node that is running a number of services, and one of them is a Node.js application powering our cart. Every entity inside Instana has a dashboard. These dashboards are automatically created for you. You don't need to configure any YAML or anything like that. And you can see here the detailed information and metrics for this specific service. The agent and the automatic service discovery was installed on this host. It discovered the Kubernetes cluster, the pod, the container, and the node process, all automatically for us. This information from the agent sensors feeds into our real-time dynamic service graph, which we can use to provide context all the way from the infrastructure to the application and the front end. So we can see our infrastructure information as it pertains to this specific process. We can look at Kubernetes metadata, and we can look at the application perspective where this process is running. Looking at the dynamic service graph. So here's our Robot Shop application. This is a filtered set of services that are reporting to this backend. And you can see we have a traffic simulator, and from there, so this is your user, and from here you can follow the traffic and the calls all the way down to the persistence layer. Here we have a dashboard for this specific application that we were just looking at, Robot Shop. And again, we can see some time series data. We provide metrics with 1 second granularity for the past 24 hours. So in a containerized environment where you may have autoscalers and containers that blip in and out of existence, we think that that level of granularity is really important so that nothing gets missed. Here on this dashboard, we can see that there were some errors in this application. Uh-oh. So I'm going to zoom in on this time frame and try and figure out what's going on. And here we can see all of the calls that are occurring across the application during that time frame. 100% error rate. Something's wrong. Okay. So looking at this, I can see a number of calls that are coming in very slow and returning 500 errors. Diving into one of these calls, I can see a distributed trace once it loads. There we go. So here's a distributed trace of that call as it and all the spans across our various services. We also have the end user information here because of our end user monitoring. And I can see that the trace terminates in a database error or connection error. So clicking on this, I can see the database entity, and I can navigate to the database service. And from here, I can see that this service is probably down. So at this point, I probably have enough information to either fix the issue or assign blame to another team and make it their problem so that I can go home. And this is a historical error that we were looking at. This occurred around 10:30 this morning. But if this were real time, Instana would alert me within 3 seconds of the error rate coming outside of the acceptable range. So that's Instana. I hope this was informative. There's a lot more to show you, so I hope you'll stop by our booth for a more in-depth demo if you have any questions. Thank you.
Alrighty, we've got one more speaker before our break. I always like to make sure the speakers feel very comfortable before getting on stage. You know, sometimes you're nervous before getting up here, so just to like make them feel even more comfortable, especially when I'm timing the sponsor talks, they get like a live countdown to exactly when they go on stage, just like second by second. It really just ramps up the stress level. Let's get that screen working.
Ooh, hello everyone.
All right, let's give a big round of applause for Owen.
I'm gonna do this one so I can actually see my slides over here. I tend to pace when I talk, so it's gonna be very hard for me. Well, anyways, this is Metrics Made to Order. I'm Owen. Nice to meet everyone. Does anyone recognize these two logos, maybe? Couple show of hands. All right, nice. Yeah, so this talk is largely about using Prometheus, and particularly how Loki rides on Prometheus' coattails at almost every opportunity. And that's largely by design. But before we really get into it, I want to talk a little bit about multi-tenancy, kind of what this means for this talk, because this is going to be going through an example scenario I had and how we figure this out. So for the context of this talk, multi-tenancy will be running some user workload on the same process somewhere. And this kind of opens you up to some weird sorts of behaviors. And so our story today starts with me getting paged, or actually not getting paged, but having a client come and talk to me and say, hey, I'm experiencing really bad performance with your application. And okay, yeah, no worries, let's go look into it. And we do, and this is kind of what we see on the bottom. And so this is called a red method dashboard. It's just a slice here. It stands for requests, errors, and durations. And so the first thing I do is I go look and I see, well, there's almost everything looks green. Good status codes. Right? Look at the latencies. Those all look fine. And what do I do now? Well, as it turns out, there's like two kinds of scenarios that I'm really scared of when I'm getting paged, right? The first one is super obvious. It's I'm dropping data, right? I'm dropping writes, client data on the ground, and now I have some really uncomfortable calls. But the second one is a little bit more ambiguous, and so that's what we're looking at here, where I have user feedback that's telling me things aren't working, but all of my instrumentation points to business as usual. And that's actually really scary because that means I'm probably going to be up all night trying to figure it out. So before we get into more on the story specifically, I want to do a little bit of primer on both Prometheus and then Loki. So Prometheus, very, very quickly, is a time series database for metrics. And one of my favorite things about this is that it has an incredibly simple data model. And I don't mean that's to disparage Prometheus at all. It's actually the opposite, right? We can build really sophisticated things from humble beginnings. And so in this example, we have, here, can you see my cursor? Oh, hell yeah, okay. So we have the queue length here, which is what we're calling a metric for this example. And then you have a bunch of key value pairs we call labels. And those point to a set of basically, timestamp and then numeric values. And that's it, right? Like, congratulations, you may pick up your diploma in Prometheology. Thank you for coming to my talk. No, but so anyways, combining these together, they're called a series, and that's it. And so this is what it looks like when you're actually using Prometheus. So on the left here, this is a PromQL query, and it basically asks for that queue length, and it aggregates that queue from every element or every component in your cluster here, so that you can get an aggregated queue from all of those individual components. Right? So you can understand the behavior of your total cluster as opposed to one particular machine, and then need to do that a bunch of times. And on the right here, remember those key value pairs, those labels? Yeah. So it's the same query, except we're summing by user in this case. And this does the same thing, right? It goes across all the replicas in your cluster and sums together these queues, but this time it buckets them into the user that's responsible for all that work. So we can see that there's two huge spikes in our queue pressure are largely attributable to one tenant, one user. So it gives us the ability to kind of aggregate and understand our data a lot better. And this may be for a lot of you, the basics, but deal with it. You have to listen to me talk. All right, so what is Loki? Loki is probably gonna get a little bit longer intro because that's the crux of the talk today. I build Loki day to day, and it is a pretty young log aggregation tool. Our 1.0 release, was in KubeCon 2019 in, where was that? California somewhere. And Loki is a time series database for strings. Right? Time series database for metrics, time series database for strings. We're cooking with gas. So my colleague Ed Welch actually coined this one, but has really, it's kind of stuck with me, so that's what I call it now too. So it is built on top of Prometheus, right? Remember those coattails? So we use the same label model that Prometheus does, but instead of pointing to metrics, now we're pointing to logs. And I think that's very powerful. And then, on the right-hand side here, one of the benefits of working open source is that you get to actually make fun of yourself in public too. This is what our data model looks like. So nanosecond precision timestamps associated with Prometheus key value pairs, the labels, and then they point to log contents. So instead of the timestamp and numeric value, timestamp and log contents. And so we call these log streams. Hindsight, maybe we should have called them series 2 for just nomenclature compatibility. But working from right to left here, I'm going to get my cursor. Where are you? We have a bunch of different replicas of different components and different Kubernetes namespaces and different Kubernetes clusters. And so this is actually roughly analogous to a log file, right? The application's coming from one specific container or application or machine. And we can use, in the same way that we query Prometheus for, to partition different data, we can do the same thing but get logs. So in this case, all the logs in, this US central cluster, right? You can get a little bit more granular as well. And this is kind of what it looks like under the hood, where we have all of these different log files which are responsible for varying degrees of throughput, and you can either aggregate or filter down to whatever you need at the time. So again, right? We can kind of deal with different levels of volume of time series, right? So all the logs in Central again, all of our component logs, slimming down the data dramatically, and then kind of refining this until we get to the actual stuff that we care about. And so that's largely how we get to the next point, which is we've been able to identify the logs, but we're not really any farther than we would be, as sysadmins or operations folk, SSHing into boxes and then grepping a log file, right? We still need to do the grepping. We've just found the logs. So I love this tweet because it's it's very illustrative of this kind of problem. And so thus we have LogQL or log query language. And again, largely inspired by PromQL for Prometheus query language, they look very similar. A lot of the same functions, a lot of the same usages, all this sort of thing. And so we want to build on the fact that we've been able to route down and slice and dice down the logs we care about, but then we want to be able to actually use the same things that we're familiar with. So this probably looks very familiar to a lot of you out there, right? Being able to use pipe syntax, being able to filter for exact matches, for regex, to compose these things together, and even some basic forms of enrichment here at the bottom. And so now we're kind of at the large aggregated distributed grep place, but I think we can go a little farther. And so this is something that's I'm actually really excited about. And a lot of time you have logs that have some form of structure. Maybe they're you have different structures across different teams and different programming language and different parts of your org. Well, we can take this, we can actually parse that structure out at query time. So in this case, we have this JSON formatted log, and we are basically extracting the field structure from it and then doing different kinds of logic. In this case, filtering down to 2 users we care about and finding the logs that have greater than 5-second latencies. All right, so if you made it this far, thanks. This is actually where the talk, in my opinion, really begins. So we've gotten this far, and what we want to do next is not just pull out structure for one log to do filtering, but what if we could take all of that structure, extract it, and then do stuff like graph it, just like we would with metrics. And ta-da, that is metrics made to order. That's what we're doing here today. So in the top, we're just getting a kind of simple count over time for all of the error logs coming out of US Central that are not timeout related. But then you can get increasingly complex. And so here we have this quantile over time asking for all of the Nginx logs, and partitioning them by the path that they access, and then in this case unwrapping or graphing by your request time. So we're actually looking for the P99, 99th percentile, your slowest logs for each path, your slowest queries. And so that's really important. By the way, quantiles are just help you answer questions like, what is my median request latency, or what is what are the slowest requests I see. This is really important when you need to answer questions like, well, our external SLAs say that 99% of our requests must be served in some duration. So if you want to talk about this later, feel free to come to me and then not talk about it at all, because there are a couple other speakers that actually have had talks on this stuff. So this is what it actually looks like when you do it, right? And wait a second, that's Prometheus, right? PromQL? No. So it turns out that Loki actually fulfills we don't just use the label format, but we actually fulfill the response types as well. So such that these are effectively Prometheus metrics for all intents and purposes, and that's why they look like that. And back in the real early days, when we didn't have the supporting cast nearly as built out, we would actually take Grafana instances and then point them to Loki and pretend it was Prometheus, and then just extract metrics from logs that way. So I tried to go and do this for today's talk, but turns out that we've made a lot of advancements since, so we can kind of detect that it's talking to Loki now, and it's like, hey, go use the Loki data source, which now supports all this stuff. So getting back to the original thing I was paged for, right? Looks like it might be one tenant, and we go and actually grab all of the logs that log query metadata. Every time a query comes in, we log all sorts of information about it. And in this case, we end up graphing, that and realizing that the worst point here, each query was spending, on average, over a minute in queue. Well, of course, it's going to be a pretty rough user experience. So, anyways, we've kind of gotten to the cause here, and it turns out that this user was dramatically under provisioned. So we would go and put them to the correct user tier for their use case, and it gave them a bunch more parallelism, everything evened out, and that's great. But that only gets us to solving this one case right now when I have a user that pings me, and that's a pretty rough engineering process, right? You can't really scale that, it's still bad user experience, yada yada. So the next thing that we really want to do is take this operational knowledge that we've just discovered and then encode it into our processes in a way that we can build like a more resilient organization going forward. And so what we're doing here is, in the same way that we generate Prometheus metrics, because we generate Prometheus metrics from logs, we can just basically trick everything else that uses Prometheus metrics, in this case, the alert manager. So we can send alert manager, these log-derived metrics, and then from that point, it'll just alert you based on what it does. And so for those not familiar with Alert Manager, it's part of the Prometheus ecosystem, and can take Prometheus alerts or queries really that generate alerts and send them to the right place. And this allows you to do some pretty cool organizational workflows, making sure that the right problems get addressed to the right people, at the right times. And so that gets us a lot of the way. Right? We've kind of looking back, we've figured out kind of how Loki works, how we can use the Prometheus label model to get to the logs we care about, how we can extract log-based metrics and treat them as Prometheus metrics, and then how we can even alert on them. And that's a big win already, but we can actually come full circle. And what I mean by that is we can actually take these log-derived metrics and then rewrite them back into Prometheus. And then at that point, they're just native Prometheus metrics, and they just happen to have come from logs originally. So you might want to do this for a bunch of reasons. Maybe you run applications that you don't actually build, third-party source somewhere, and it's not instrumented the way you like, and you can't really change that, but you do have access to logs, so go write some logql queries, extract the Prometheus metrics, right? And then you've built your own DIY exporter at this point, and then you're just writing the metrics back into Prometheus itself. You can also do the kind of other common use cases here, like pre-computing expensive queries, and once you have the metrics in Prometheus itself, you can query the log-based metrics alongside the traditional Prometheus ones, like within the same query, which has a couple of interesting use cases. So we do this by what is called recording rules. Shout out to Danny Copping, part of the Loki team that actually implemented this once Prometheus merged remote write proper into vanilla Prometheus. And so that's kind of how it works under the hood, right? Instead of alerting on them, you just rewrite them into Prometheus. So what does this allow us to do in our example, right? So we found the root cause, right? We've developed this operational knowledge, and now we want to re-encode that. We've sent alerts out. We can generate Prometheus metrics, right? Turn them into dashboards, right? And we're basically building a more resilient, more adaptive, stronger engineering process internally that helps us make sure that we run and diagnose things much more quickly. And so there's probably a couple of y'all out there that may be pretty familiar with building, using Prometheus at scale, and some of this might sound a little weird, right? Aren't high cardinality metrics pretty nasty? And isn't that what per tenant metrics sound like? And the answer to that is a little bit more nuanced, but generally yes. So this is kind of the problem in vanilla Prometheus. Let's say that you have, you want to expose per tenant metrics on every single pod, and there's a bunch of metrics and a bunch of users. So you actually end up needing that's a multiplicative problem. And the little bomb right here is what we call a cardinality explosion. So, for instance, you have 100 containers, right, that are generating 100 metrics for 100 users, right? You're generating 1 million time series. You can quickly see how this gets out of hand, right? If all of these hundreds are thousands, that's 1 billion time series. And at that point, you probably need to go to Oleg's talk tomorrow on scaling Mimir to 1 billion active series. Shameless plug for a friend of mine. And then, so Loki works a little bit differently because we are actually extracting this structure from log lines themselves. It's kind of like the difference between potential and kinetic energy, right? There's all this kind of embedded cardinality inside these logs, but we can kind of choose when to access them. And so we're really only querying 100 log streams, right? 100 log files, and extracting the combination of 100 metrics times 100 tenants from that. So it ends up being 10,000 series as opposed to 1 million. And so this is probably the most important slide in this whole talk, because it's largely how we've been using Loki and Prometheus together for the past year or so. And so kind of from top down here, make sure that you're ingesting logs into Loki, however you want to. And then you use, you go through what we just did, which is, in the middle of some outage, right? And we're triaging everything. We go look at logs, right? Because maybe our metrics don't answer what we need them to. They don't have the degree of granularity that we care about. But we can use the logs and then derive metrics from logs to continually basically build a hypothesis, answer it, validate or invalidate it, right? And continually refine that until we get down to the point that we feel comfortable knowing what's going on. And that's a lot of work that we've just done. And so ideally, then we just take that bit of process and we encode it, right? Ideally as code, right? As alerting rules, as recording rules, to rewrite them into Prometheus, to build dashboards on top of them, to increase the knowledge base of our own engineering work. And so, kind of skipped over a couple of these here, but yeah, we use them at the bottom to notify, and then ultimately, observe them as Prometheus metrics. And this has been something that we've used to great effect, over the past, really, really using it to its highest potential probably in the past year or so, but in various forms for a few years before that. And that is it. Thank you for coming. I will definitely take a couple questions, but how fast was that? I feel like I just tore through it. You practice and it's all super slow, and then you get up here and you talk like this. Any questions, anyone? Yeah, none, all right. After lunch crowd or just poor talk, right? All right. Yeah, no worries. Well, thanks for coming, everyone, and take care. Feel free to come find me in the hall and yell at me or whatever.
So we are going to move into a break right now. It's going to be our last break of the day. And we're going to meet back in here at 3:45 for the last two speakers. One of them is actually Jason and myself. We're filling in for a speaker who unfortunately could not make it. And we're going to be looking at the history of Monitorama sponsors and just as the monitoring entity. So we thought it was particularly funny as we talked on a Zoom about it. Maybe it will be funny. Maybe it will totally suck. We'll find out. See you at 3:45. more talks left before the sponsor parties. As a reminder, those sponsor parties are in the Tuesday Night Lights channel. Thank you to one of the attendees who put together the awesome, map, walking directions in there. Try to hit up a bunch of those and support our sponsors. Our next to last speaker is it's kind of a funny memory of this community is so small that you oftentimes will follow people on Twitter, or at least I do, that I will have never seen their face and I have no idea what their actual name is. But then when you finally meet them, not only do you then figure out what they look like and what their name is, it turns out you actually have a bunch of shared connections. And that's actually our next speaker, who is someone that I've probably followed on Twitter for, I don't know, maybe a decade, and really met for the first time like 2 hours ago. So with that being said, I want to welcome Matthew to the stage.
Thank you. Let me just move this a minute, hang on. There we go, that's a bit better. Hey, loads of people turned up for this. This is awesome. So my name's Matt Wallace. I'm a principal consultant for an organisation called Contino. We are a consultancy. Please don't groan, we're not that kind of consultancy. I'm here because we do a huge amount of work around Agile and SRE and all of the rest of it. And we have quite a few people that we talk to who are like, yeah, we do SRE, and we're like, okay, great, where's your observability stack? And they're like, well, we have logs. Right, okay, cool. So what we tend to do is we tend to sit down with our customers and we work out what it is they're going through, where their pain points are and how we can help them and all of that kind of thing. And then we come in and we train up all of their staff and we help their staff build the platform. And then we leave. And we leave them to run the platform that they have helped design, that they have helped to build, that they know how to run. So we've been going for a few years. There's 500 of us globally, more than that now. We've got offices in New York, we've got offices in Sydney. I'm based in the UK. And yeah, it's a fantastic company to work for. I actually came back to it precisely because we won't dump 400 consultants on site for 2 years to build you something that probably doesn't meet what you actually need by the time it's released, and then charge you more money to put more consultants on site to actually run it for you. I love this idea that we actually educate people, we educate our customers, and we bring them with us on the journey. We are hiring. If you're interested in jumping ship, if you're looking for new opportunities, if you'd love to get into the world of consultancy, please come and find me. I'm here. Well, I actually don't fly home till Friday, so I'll be holed up in a hotel until then. But yeah, find me at the conference, find me at the end. I've got, my details are coming up on a later slide. So what am I going to talk about today? The talk is about automating the deployment of SLIs and SLOs. So from that, I'm assuming that based on all the talks that you've seen so far or previous experience, everyone's reasonably familiar with SLIs and SLOs. Okay, so I'm going to skip that. But the goal is that we end up automating as much as we can. So we're going to look at the tools that we're using to do this with some of our customers. We're going to look at the process that we go through, the result. We're going to look at some alternatives as well to the process that we're moving, because this is specifically targeted at folks that are running Loki, Prometheus, and Grafana. But there are other tools out there that will work with Datadog, that will work with New Relic, and all those kinds of tools. And then hopefully, if I've timed it right, there might be some time for questions at the end, but otherwise, as I say, I'm here till Friday, come and find me. So what do we want to achieve? The whole thing for me about SLOs and SLIs, and we've already had a few talks around this, is that it has to be manageable by the developers or the people that are going to be responsible for reacting to these. Okay? So we have to come up with a way that we can do straightforward generation of the queries that we're going to be running inside our observability platforms. We really want to be using some kind of common format, and we've seen some really good talks so far about that as well, the annotation of classes or that kind of thing. And it needs to be something that's accessible to everyone. We shouldn't need to get someone who's an observability wizard involved in writing these SLOs and SLIs. We should be able to get the business to write them. We should be able to get the developers to write them so that they sit alongside the code base.
And we want to be able to automate the way in which we deploy it, because you don't want someone taking up all of their time, sat at a desk clicking buttons in a web interface in order to generate this stuff, right? It's a nonsense. We automate everything else. We automate all of the testing. We automate deployment of our infrastructure through Terraform and all of this. So why shouldn't we automate the way in which we deploy our SLIs and SLOs as well? And it needs to be really simple. Okay, we shouldn't need to go off and build huge, complicated tool sets that were once, the kind of bobscript.sh, and then Bob leaves and it becomes davescript.sh, and actually it restarts on a cron job every 5 minutes because the server it's on is so old it can't cope. And we don't need any of that. We want this to fit into our existing continuous integration, continuous deployment patterns. And because we're a consultancy, we actually need this to work across multiple CI and CD tools, because we're going to be taking this into multiple customers, and some of them are running Circle and some of them are running Jenkins still, and others are running, Octopus Deploy or whatever it is. So this needs to work across all of those. So that's our goal. So the tools that we're going to use to do this actually come down to 3 things. And you'll excuse me if I duck down for water. It turns out gin and tonics are mixed far stronger here in the US than they are back in the UK. It was good fun though. So the tools that I'm going to talk about this afternoon. There's one called Sloth. All of these are open source, by the way. It converts YAML from various formats. They've got their own format. They've got a Kubernetes format, which is kind of Helm chart style YAML. And then there's OpenSLO. I'll talk about OpenSLO in a minute. The OpenSLO support is not quite where we would like it to be. But again, I'll come on to that, but that is changing. Going to look at something called Cortex tool. How many people here are running Cortex as opposed to Prometheus? How many people knew there was a difference between Cortex and Prometheus? Okay, cool, right. So for those of you that don't, Cortex is basically a way to cluster Prometheus, if you like. It's not actually Prometheus itself, it's a standalone interface compatible project. And it's just a way of sort of scaling out Prometheus so that you're not running a staggering number of Prometheus clusters and trying to work out which one you should be connecting to see which data. There's a great thing called Cortex tool. It's a really easy way of manipulating and adding and controlling Cortex via the API. The folks at Grafana migrated away from Cortex to Mimir with the event of Grafana 9. There is Mimir tool. We are starting to move over to that because a lot of what we do is in Grafana Cloud. For those of you that didn't see Corey's talk yesterday about build versus buy, where we kind of sit is in the middle. It depends. So it's really nice to see him sort of coming to that conclusion as well and talking about that. And what we tend to do is we tend to say, certainly with the observability stuff, right, running all your data storage stack and your data analysis stack and everything like that, make that someone else's problem. Because that's going to cost you a small fortune in wages, never mind anything else, to have the team to maintain the Cortex clusters or the Elk stacks or the AppDynamics clusters or the Splunk clusters, whatever they are, right? So make that someone else's problem. But the data collection and augmentation such as labeling and stuff like that, that is something that you can do in-house. So we tend to put tools like Vector or something like that in the middle to do the collection of the data, and then it pushes it off into the SaaS thing. Because we're interacting with Grafana Cloud, that therefore means we're effectively talking to Cortex or now Mimir, so we need to be using the tools that talk to that as opposed to something that's Prometheus specific. And like I say, we're using Grafana Cloud, but we'd probably be using something like Prometheus anyway, and there's a number of reasons for that. The first reason really is that from an open source point of view, this really is now the de facto metrics store. Right, I mean, you spin up anything that's Kubernetes related, your stack is going to probably come with Prometheus pre-launched. It's certainly if you get it from a vendor, you're running whatever the Red Hat managed Kubernetes thing is. OpenShift, isn't it? Yeah, because OpenStack's something else. So yeah, the chances are you're going to end up interacting with Prometheus. So for a lot of the stuff we do, it's Prometheus. But also we did an analysis about 8 or 9 months ago for one of our clients, looking at 5 SaaS monitoring options based on cost, and that includes the cost of the wages to run it if you run it locally, based on the features that our client wanted and additional features that we thought they needed but they didn't realize that they needed because of where they were in their journey. I won't name the other competitors in this. Suffice to say they are all here with stands upstairs, but Grafana Cloud came out top. So therefore, for this particular client, that may change for other clients, but for this particular client we're doing this for, it's Prometheus. So those are the tools that we're going to be using. I just want to talk a bit about OpenSLO. This is an example of what it is. OpenSLO is an open source project. There's a few people here that are contributing to it. And the idea is that in YAML you can create all of the details of what your good queries are, your total queries are, your alert thresholds, your alert triggers, everything like that. And then there is a tool like Sloth, or the one that in the OpenSLO community that's rapidly gaining maturity is Oslo, and it will take your OpenSLO description and then, and this is just about to be merged and released, I hope, it will start to convert it into whatever the format is needed for the API of the SaaS provider you're using. So the first one's going to be a company called Noble9. I'll talk about them right at the end. But also for Prometheus, it will create the recording rules and the alerting rules. And we're hoping to get it for New Relic and Datadog and all the rest of it. So you'll be able to write all your stuff in one format. And if you decide you want to change your monitoring provider at some point in the future, you just change the flag you pass to Oslo, and it will generate all of those SLIs and SLOs again for you in the right format, and you can upload them to whatever it is you're using. OpenSLO.com is the website for that. Again, there's a few of us around, so if you want more information on that, come and find me. And then the final thing to mention before I move on to sort of how this all hangs together is the SLO DLC, which is the SLO developer lifecycle. So this is something that we announced at SLOconf back in May. Again, it's a fully open project. There's all kinds of people that have worked on it, Noble9, Ford, ourselves at Contino. And what we've got, although it's not that easy to see from this image, unfortunately, because of the colours, is it's literally exactly the same way you do something like the Deming cycle or something like that when you're writing software. This is the same thing but for SLOs. And it's got a handbook up there, and it's got a load of templates for you that you can go and fill out with the people that have got vested interest in your platforms, all of that kind of stuff, to help you make sure that when you write the SLOs and the SLIs, they're actually going to be useful and they're going to be meaningful. So again, more than happy to chat about this afterwards, but it could be a really good resource for people if you're looking for that kind of thing. And if you look for the for the SLOconf website and the videos from earlier in the year, there's 3 or 4 videos around this that would help you understand exactly what we're going for. Okay, so that's the tooling and some sort of paraphernalia around the outsides dealt with. Let's have a look at the actual process itself. So this is a very badly drawn diagram of what it is that we do. Like other presenters, I'm used to sort of dancing around and waving my hands, so I'll sort of do this from this side. We use GitHub for source control. That's irrelevant here. It doesn't matter what source control you use. Doesn't matter which CI/CD tooling you use. That's the whole point, right? So in GitHub, we've got YAML. When you do a pull request, you do your standard reviews, that gets merged, and the CI kicks in. And that's the point at which Sloth takes over in our case, and it reads the Sloth spec that we're using, and from that it generates the recording rules and the alerting rules for Prometheus, and then Cortex tool uploads that into Grafana Cloud, and Prometheus Alert Manager takes over at that point and starts doing the comparisons between the recording rules and the alerting rules and triggering the alerts into Slack or whatever, and we can graph it in Grafana. The talk, how many of you attended Owen's talk before the break about Loki and stuff like that? Okay, cool. So he started talking about using Loki recording rules to create metrics inside Prometheus, right? Sloth works really well with Prometheus. It doesn't work very well with Loki. That's because when it was written, Loki wasn't really a thing. So what we're doing is we're doing exactly that. We're actually writing the recording rules into Prometheus based on Loki queries, and then we're using Sloth to analyze the recording rules from Loki to actually trigger the things. I can go through that again, but it's actually a lot easier to show someone than it is to do a live demo or to talk through it. So this is what Sloth code looks like. You'll notice that this is for a home Wi-Fi. This is actually one of the examples that comes with Sloth. Any of you that have got Unify kit on your networks anywhere, if you use the Prometheus exporter for Unify, then you can actually just download these examples and you can start getting things like burn rates against client satisfaction on your home Wi-Fi network, which is great because it means that when my kids come to me and go, "Dad, the internet's not working," I can go, "Well, no, actually it's fine. Here's a graph that proves it." I'm not that popular when I do that. So, as you can see, it's fairly simple. You know, we're talking about the events, and you've got the error query and the total query. We've got what the objective is, a description, some labels, all of that kind of thing. And you know, again, here you've got two SLOs. You've got good client satisfaction and you've got risky client satisfaction. So for those of you that don't know the Unify setup, it does all sorts of clever things and then tries to work out which of the clients aren't doing very well and can't see the network well. So this is basically giving us an idea of which clients are causing us the problems. So then we run Sloth against this, and that's the entire YAML file, by the way, for the SLOs, okay, as far as Sloth is concerned. It then generates a ton of recording rules and all of the rest of it for Prometheus, which is what you can see on your screen here. So I don't actually need to worry about writing these expressions where you've got the sum over time and the count of the polar and the ratios and everything like that, and doing it for 5 minutes and 10 minutes and 30 minutes and an hour and 3 hours. Sloth does all of that for me. All I need to do is just say, yeah, so the error query is the sum over time, the total query is that, and it will work out all of the incrementals that I need. And it will give it labels, and it will give it tags and everything like that. So when you go into the dashboards, you can pick it all up. And it's this output that we then run Cortex Tool against. And this is what you get from Cortex Tool. And so, I mean, it's not particularly interesting, but it just shows you that it's posting all the stuff up to the Cortex API. And this is going into, actually no, this screenshot is going into a Cortex that runs on my home network, because I'm quite sad like that. I have the entire Grafana stack running on a small box hanging off the end of my network, and it is clustered as well, because, you know, why make these things easy? So anyway, so that's what you get as the output from Cortex Tool. It's reasonably readable. You can grep through it, you can see where things have failed. It will exit with sensible error codes as well. So if this fails to upload, your CI pipeline's going to stop. Same thing with Sloth. Sloth can validate the YAML before it creates it, so you can get it to stop the CI pipeline if the YAML doesn't validate. So we use that step in PRs, and you can get it to stop the CI pipeline if it can't deploy the SLOs. The way we have it set up is that it deploys the SLOs and the SLIs before it deploys the application. So if the monitoring in the observability isn't going to go out properly, the application doesn't go out. So what do we get? Well, again, I don't know, how does that show up on the screen? Okay, I think. For those of you that are familiar with Prometheus, you'll recognize the alert manager inside Grafana. And this is what the output is effectively of Cortex. It just generates all of these rules. And they just turn up. You don't need to do anything in the UI for that. And then, as you can see there, you've got all the expressions in there to work out what the various burn rates are and everything else. And like I say, all of this has come from the code generated by Sloth, and that's just been uploaded straight into Prometheus Alert Manager, or Cortex Alert Manager in this particular case. One of the other reasons to use Sloth is that it comes with 2 dashboards that are pre-configured to automatically pick this stuff up. So it gives you an overview dashboard. And this is literally just, this is how many SLOs you've got, this is how many are at risk, this is what your burn rates look like, and things like that. And then it gives you a detailed dashboard. Now what you can't see very well on this detailed dashboard is that up at the top there's a series of drop-downs. It will automatically populate those drop-downs with a list of all of the SLOs that it knows about, and then when you select an SLO, you can select the SLI, and you can select the time window that you want to look like, and things like that. That all comes for free. You lift 2 dashboards into Grafana off grafana.org, and it knows, because you've got Sloth in there, it knows what the format should be, and it just picks those up. So that's another reason we use it. You can see as well, it's showing you the objective, it's showing you what the current burn rate is, it's showing you, where it's got no data, that's actually another burn rate that's over whatever the time window is that you've selected from the top. As you can see from the graphs, when I actually took this screenshot, the data hadn't actually made it in. All the SLOs and SLIs were in there, but the data wasn't going in there quite yet, so that's why some of these are blank. But you will see some of those graphs at the bottom. You will actually see over time how quickly you're burning down your error budgets and things like that as well. So it's a really useful tool to just be able to go to the dashboard, SLO, SLI, job done. And because all of these are in Prometheus Alert Manager, it also means that you can set up the triggers so that if the error budget looks like it's going to be breached, or you're burning too fast or whatever, it automatically sends a notification into Slack or to Teams or to PagerDuty or to ServiceNow or to Jira or whatever it is, wherever it is you do your incident management. If you're using Grafana Cloud, they also have, as of 2.5 weeks ago, 3 weeks ago, they now have their incident management stuff live. If you can get access to the beta to that, I'd highly recommend it. I've started playing around with it with the hope to use it with a different customer, and it is really good. It's rock solid. It'll allow you to spin up incidents, assign incident commanders, assign engineers, everything like that, either from within the Grafana UI or directly from Slack using a ChatOps bot style thing. So yeah. So that's kind of it as far as the Sloth stuff is concerned. I do want to take a couple of seconds, firstly to have another drink, and then just to have a look at some of the alternatives. Okay. So we focused, as I say, you've seen we focused on the Grafana stack up until now, and as I said, there's reasons for that, but there are some other options out there. So one of them is Noble 9. How many people here have heard of Noble 9? Or are using it? Okay. So we kind of found Noble 9 through work we were doing with another client, and then we discovered that they were doing all the stuff around OpenSLO and the SLO DLC, and now we're looking at their product and how we can put it in. It does have an API. You can do all of this via the API. But the user interface is actually so intuitive and so easy to use that for a lot of teams, I suspect that once their data is starting to be collected, it's actually going to be quicker for them to click through and then do an export so that they can then save it and post it through the UI. It is really good if you don't want to have to manage all of this yourself. If you want to outsource as much of this as possible, then it's a great service for that. And whilst they will integrate with Grafana Cloud and on-site Prometheus and things like that, they'll also integrate with Datadog, AppDynamics, Splunk, Elastic, New Relic, and there's more coming out all the time. Okay? And as I say, it'll integrate with Prometheus, which is where this has come from. And it's a really simple integration as well. They have a container that you run. And you say to the container, that's my Prometheus server. And it goes, oh, okay, great. And then all the data is available to you inside Noble 9 to do all your queries. Other alternative is a company called dtech.ai. They're based out of Israel. They're still quite early in their progress, but they're doing some really cool stuff, and I think there's a lot of promise here, so they're one to keep an eye on. They don't support as many people as many providers as Noble 9. They've got AWS, Google Cloud, Prometheus and New Relic, Elastic, Pingdom, Datadog, Instana and Azure are on their way. Again, it's very easy to set up. But one of the things I love about DTech is that when you go into the user interface to create your SLOs and your SLIs, it says, oh, I've been looking at your data and I found a metric that's called HTTP response times. Is that something you'd like to make an SLI from? You say, well, yeah, actually that'd be great, thanks. And it says, okay, well, what do you want the thresholds to be? You know, what's your error rate? You know, what does bad look like? What does good look like? Whatever it is. But the fact that it actually prompts you for those initial errors means that if you're working with teams that are perhaps not as mature as they want to be, and they're just starting to get to grips with SLIs and SLOs, then DTech could well be a good place to start because it's got this automatic recommendation. And that's it from me. If you want to get hold of me, if I've made glaring errors and you want to tell me publicly how wrong I am, I'm available as Prof Falcon on Twitter, Slack. I am still on IRC as well, for those of you that are, been in this game far too long like I have. Feel free to connect on LinkedIn, drop me an email if you've got any questions. I'm happy to. I think I've got time for a few questions now, but otherwise I'll be wandering around all over the place. And despite the gin and tonics last night, I will be out again this evening. So that's it. Thank you very much.
Yeah, we do have time for a few questions if there's any questions. And we got one right up here, and then just repeat it.
I was just curious if you can speak to possible approaches you might have done with regards to testable SLOs. And like when someone chooses to establish an SLO for a new service, how to make sure that they're not going to have the wrong threshold and like cause spur of alerts to happen.
Cool. Okay. So the question was effectively, how do you test that the SLOs that are going to get launched are the right ones? Yeah, is that
right? So some services might have already a lot of historical metric data that they can build informative SLOs.
Yeah, cool. Okay, so the short answer is at the moment we don't really have a good answer to that. We tend to do it's more of a review of the SLOs and the SLIs during the pull request. So they'll be submitted and you'll read through the YAML and you go, actually, yeah, okay. And we might cut and paste the queries that are in the YAML into Grafana to make sure that the graphs look right. We may even go as far as creating the recording rules. So we run sloth to do the output and then actually manually put them into a dev Grafana or something like that where we're sending some data. But it's very much a manual process at the moment. We would love that to be more automated. It's something we're working on, but we're not there yet. Any more? Any other questions? Stunned silence. Fantastic.
Awesome, great, thank you so much.
Thank you, cheers.
All right, we have one last talk. Unfortunately, the speaker that was going to fill this spot was came down with an illness, and they were not able to make it. So Jason and I decided to, do something, which is what we're going to do here. Jason yelled at me before because somehow I both oversold this talk and undersold it. So I feel like that's me in a nutshell. So now we're going to wait for like 5 minutes for him to actually unwrap the power. He's got to like boot his laptop up.
Any fans of the Framework laptop here? All right. If anybody is interested and hasn't seen one, you can come ask. You can come check mine out. Yeah. Yes, I actually have HDMI here because it's a Framework laptop and I can just plug one in.
He is really passionate about this Framework laptop.
We'll just look at Jason's tweets.
No, we're not gonna do that. Do we need to do anything with the notes?
We'll hit present.
Let's see if we can actually see the notes. Oh, can you do the like, I don't know, extend or something?
Oh, wait, you don't want display mirroring?
You have to actually pay for the separate module that allows you to extend. But it's fine, it's user replaceable. You just pop the little thing. Oh, yeah, there we go, extend it.
Extend?
Yeah.
25, what resolution is that?
I think it's 2560 by 1440, I believe. All right, so I want this one over here.
Yeah.
Wait,
what happened?
No, Jesus, where am I going? Where's this going?
Old man's computer. Just he's gonna look under his glasses while he actually.
Where am I supposed to put this?
I have no idea. Can you drag it up to the top?
I guess, but this isn't gonna help, is it? Which one's desktop one? Which one's two?
This is thrilling content here, I swear. This is all simply because I put some details in the notes, and I tried to actually pull it up on my phone, but you can't view. Does anyone here work? Here's the question: does anyone here work for Google? Raise your hand. Show yourself. Do you work on the Google Sheets product? I would like an introduction to that product owner for no reason whatsoever. It could be so much better, I swear.
Okay, so there's me. Okay, where's my browser?
Does anyone have a framework that knows how this works and can teach Jason how to use it?
Shush. Okay, I got it. Now I just drag this guy.
Yeah, drag that over.
Come on. There we go.
Yeah! Yeah, round of applause. We have figured out.
All right, how do I make that thing full screen?
Go to the little full screen thingy. Yeah, there you go. Close enough. Don't.
Hold on. F11? You haven't seen my keyboard. I swapped out to the keyboard that has no.
It's all clear. All the keys are clear. There's nothing on it.
It's a feature. It's security. Okay.
Nope, that's not F11.
Eliminating users works pretty well.
That's F.
Wait, no.
Nope, that's volume. The poor people watching the live stream are just like, you know what? Forget it. It's really not worth it. And I forgot that we have our wonderful translators here translating this complete hot mess right now. This is fine. Just make the text bigger because I'm an old man.
We hide bookmarks.
No.
Is that good?
That's fine.
Is that okay?
Okay.
Okay. All right. How's that? All right, cool. All right. So a little background. We're gonna jump back and forth a little bit. What are you doing? All right. Okay. So someone asked me this morning, like I don't remember what the context was, but like, well, how did this start? Like, this isn't really an interesting story, but in the context of this talk, I guess it's sort of interesting. Monitorama started as like, the idea was like a hackathon. Like, back in the day, 10 years ago, I mean, pretty much all we had was open source stuff. So Graphite, Ganglia,
Nagios.
Yeah, Nagios,
Nagios.
RRD tool, stuff like that. And I really, I knew a lot of people in the community, folks like Jordan Sissel, folks like that, and I was like, what if we like got everybody together as like a kind of an add-on day to Surge? And show of hands, who's been to Surge before? Yes.
Yeah.
Okay. A few. Okay. Really excellent like scalability conference, and I was like, well, what if we got everybody together and kind of did like a hackathon, and it like kind of became its own thing, and we took over the Nerd Center in Boston, and I actually think this is when we met at like the after party or something. So.
Yeah, it was either, we were actually trying to remember this one, because again, back to the whole like pre-Slack, right, where every community was in Slack, the olds in the audience were on IRC. And there was a channel that was, I don't even know what it was called, but it doesn't really matter, but so many of us were just in these IRC channels complaining about monitoring, and I think there actually was a channel called Monitoring Sucks for at least a year. Yeah, the monitoring love thing actually came out of DevOps Days Rome, though. I actually gave a talk there. Coincidentally, it was somebody completely different that actually coined it, but yeah, that's where that came from.
So basically, there was a lot of people who were upset with the current state of monitoring, and I think we were all coming to the same conclusion at the same time that, like, we can make this world a better place.
10 years later, we're all thrilled with monitoring.
It's solved problem, right?
So, all right, jump forward. That's just a little bit extra context, how this whole thing kind of started. It's interesting. I don't remember why, but this week I started looking at, all right, so I'm not a visual designer. My daughter, who a lot of you have met, is actually a graphic design major. Me, I'm, former systems administrator, current engineering manager. Adobe tools are not my jam, okay? But I managed to take enough every time to, put some new logos in, swap them in, make signage like what you see out in the lobby. But one of the things I do to cheat sometimes is I'll take like the web page, which has a bunch of the small logos at the bottom, and I'll squish it together, and then I'll take a screenshot of that, and I'll use it for some other asset, and that becomes a thing. And I started to look at some of the older events, and I was like, it's really interesting to see some of the companies that used to exist when this started, and how this has evolved over time, and how, like, the trends. I mean, we talk about now, one of my big things is getting enough practitioner relevant content to make an event like this. So I think that's really important. I think there's some fantastic vendors and sponsors out there, but I think the folks who are using these tools really have to understand what's going on behind the scenes a lot of times. Like we talk about AI and ML, and I'm going off on a rant now, that's a whole other thing, but I think it is really important that we understand what we're trying to solve and how these other tools are helping us solve them. So anyways, going back to the original topic, I haven't even gotten a slide 2 yet, but that's why this came about. I thought it was really interesting, and we just started laughing our asses off when we started looking at some of these old companies. So that'd be interesting to kind of walk through the past.
And clearly, if it's funny for us, it'll be hilarious for everyone else. But what I think was fascinating, and we'll go through these, is just not only the evolution of companies and their logos, which I always find to be pretty interesting, but also consolidation in the space as well. I would ask if there's any VCs in the audience, but they're way too smart to actually let you know who they are. So, but it is really fascinating to not only see as well the monitoring companies and the evolution of what types of monitoring companies would sponsor, but then even in the original Boston one, you have a lot of companies who sponsored it that were for hiring purposes, right? Like career-based.
Yeah.
This one I actually just want to call out 2 things here before I let Jason talk, is GitHub's logo. This was back in the time of lowercase, right? Lowercase g. Also social coding, because that was, that's like everyone is a low code company now. Back then, you all had to be a social company. They dropped that pretty quick. And then the other one that I wanted to call out, just because I worked there with Sean Porter, was Sonian, which no one's ever really heard of, but Sensu was born out of that company. And so, we obviously sponsored it because we wanted to support that project.
So a little known fact, I was working at GitHub when this event took place, and you had said that I guess GitHub had like a house in Boston, like we'd rented out a whole house and they were staying there, and that was actually, we had actually had the whole GitHub ops crew was in force at that event, and that was actually a lot of fun. Librato, their logo didn't really change. I mean, they had a good logo to start with. I ended up working with them later. Joe Ruscio, who I don't know if he's here today, but he's been here for this event. He tried like 3 different times to recruit me, and I finally relented and had a fantastic time there. Datadog, Mozilla. I think Mozilla was there recruiting largely.
Yeah, exactly. I think, and I'm just noticing too, like again, PagerDuty's original logo. My joke about PagerDuty is not a bad thing, but they might be the first company that original product was based on Twitter Bootstrap, maybe other than Twitter, who went public. Like if you remember, the really early version of PagerDuty was all like Twitter Bootstrap. But look how many other logos are all lowercase, right? As was the style.
Can we pour one out for Basho? Does anybody remember Basho?
Yeah, pour one out Basho.
Yeah. Fastly, the reason Fastly was a sponsor was because they actually sent someone to the event to live stream it. We had a terrible time because the Microsoft Nerd Center Wi-Fi was just utter garbage, but it was, years later I ended up working for them. Frankly, half of the logos on here I probably worked for at one time or another. I kid you not,
This is actually just an export of his LinkedIn.
This is a visual representation of my career, that's right. Circonis, I was the original product manager. I was terrible at it, but that was the original product manager for Circonis.
Tumblr, I have no idea why Tumblr.
I have no idea. This was obviously pre-Yahoo or whatever happened.
Can we get a shout out for the original, like, old school PagerDuty logo? Like, that's wow.
Yeah, that was. I mean, I'm sorry to the PagerDuty designers, but you knocked it out of the park with this one, and you should have just stuck with it. It's just.
I don't know if we can see the Cumulus one. I want to see if I can actually zoom in on this.
Oh God.
Oh wait, can I not zoom?
No, don't. Please don't.
Oh,
God, what are you doing?
I have to. No. Should
No, don't do it. Oh God.
Hold on.
That's an old man tool. He knows how to use it.
All right, just go to the next slide, man. We gotta move on.
I'm committed.
We got like 8 more
All
years to go.
right,
Okay.
I'm committed to that meme. I'll drop that one in later.
All right.
Let's see. All right, Berlin, 2013. You'll see this as a pattern. I guess I don't know if it's a pattern if you only had 2 European events over the years, but definitely fewer sponsors over there. I think it's a different type of an environment over there in terms of monitoring. Although I gotta call out like Airplane. Any Influx data folks in the house?
I was gonna say, who here
do
knows
you even
Airplane?
know that your company started as Airplane? Is there anybody from Influx in the house right now?
They went to the bar.
Nobody's willing to admit they work for a company named Airplane. No, actually, it was a really good logo and a really good, really good name from Paul Dix. But, yeah.
The other one I like to call out here is OpsWorks, and you're probably thinking to yourself, like, why is a service inside of AWS sponsoring Berlin? And it's because back then Amazon actually liked to acquire these small kind of 2-pizza team companies, and this was the Scalarium team, if I'm remembering right. That were acquired into Amazon, ended up becoming OpsWorks later.
Yeah. Server density, I think later on became Scout APM or something like that. How about DNS Impl, as I prefer to call them?
I don't like that at all.
I think there's as many Elasticsearch logos as there are slides in this presentation. So.
We're gonna keep an eye on Elasticsearch because amazing evolution, and we're gonna talk about each one of theirs.
Let's see.
But Librato, though, they will hold out strong until they don't anymore. All right, so what? Oh yeah, first year here, right? First year in PDX.
First year in PDX.
All right, so this one I looked at, and I actually spent a bunch of time on Crunchbase because I was really honestly trying to figure out what happened to so many of these companies. It was kind of funny to see things pop up and things go away. You'll start seeing some consolidation as well, which we'll talk about. Basho still sponsoring, like shout out to them.
Now I'm a little confused though. Like, so this happened when we worked together at Dyn.
Yes.
But then this also happened when you left Dyn and worked for ThreatStack. So like, what's the chronology on that?
Yeah, I think this is actually where I met the ThreatStack founder, and also hilariously, both of us actually quit Dyn. At this conference with our boss here. I have this distinct memory of Jason and I having a coffee, and then our boss comes over and is like, how's everything going? And Jason just goes, yeah, man, it's just not really working out. And I'm like, oh, I gotta go. And he like literally quits right in front of me. So then of course my boss is like, well, how are you doing? And I'm like, I don't know, I'm kind of with Jason. I don't think it's working for me either. So I really feel bad for my boss. That happened there. The one I did want to call out though, actually there's 2 I'm going to call out. The first one is Stackdriver. So Stackdriver sponsored this event. Not one single Stackdriver person showed up to this conference. And I remember looking at all the badges because like there were friends of mine who founded Stackdriver, and I looked down, I was so excited, I hadn't seen them in a while. I'm like, God, where are they? They're not here. And I texted them a picture of their logos, and that week they were actually getting acquired by Google, which is why they weren't here. So they had sponsored it, and then they got acquired during it. The other one...
Wait. Oh. Can anybody raise their hands? Do you have any idea what Grok did?
That's what I...
Did anybody?
Did you figure
Okay, because we don't know either.
I reverse image searched this logo. No hits. There are no hits on Crunchbase. I don't believe this company ever existed. I think we could have just created our own logo, and you would have been like, yeah, Grok, I remember Grok. You didn't use them?
Does the AI as an API service, does that ring a bell to anybody? Like you send your data to them, your monitoring data, and they do things and supposedly alert you. Like, I think that's what it was.
There's a new company called Grok.
And Grok.
That's a different one.
Yeah,
There's like another Grok too.
Oh, okay.
Yeah, I don't know. If anyone knows anything about this company, I'm dying to figure it out because I cannot locate them.
And a shout out to Puppet Labs, OG logo, and also they hosted our first after party down the road on 13th. So that was pretty cool.
Oh, and Influx.
That's first Victor Ops sighting, yeah.
And
Salesforce, that sad, lonely little cloud down there. Yeah. That's a larger retrospective on our entire industry, I think. Sad, lonely little cloud.
Part of me wanted to not that we wanted to spend literally any time on this talk at all, but we wanted to take some of these logos and have them progressively get larger and larger as they just gobbled up all the other sponsors here. Just read into that however you will. Things get serious here. This is like this amazing explosion. People have realized that this is a real conference, and a lot of, I guess, investments are happening here.
Yeah. Pancakes, remember Pancakes worked for Opsmatic.
I can't even see Opsmatic.
Mikhail Panchenko, remember Mikhail? Pancakes worked for Opsmatic.
Let's call out Moogsoft's like OG logo.
And well, all right. Props to Moogsoft for finally changing the logo. No offense.
You're welcome.
All right, I actually forgot the last slide to keep an eye on Elastic, but we do have not only a logo change, but also a branding change. They dropped the search. They don't search anymore. They're just Elastic, and they got the new little bubble logo here.
Yeah. I don't remember what is Runscope? Are they still a thing?
They still exist.
Do they?
Blaze Beater.
Okay.
The other one here that we could not locate any information on was JUT, J-U-T, that one right there. Again, no, they don't exist at all. They really don't.
Shout out to Rain Tank.
I have a Jet pipe glass that you need to reinvent that year.
It's real.
No, I'll send you a picture.
Yeah, it is kind of amazing, just like some companies, I mean, we haven't even mentioned Datadog, right? They sponsored the first one. They're like a $350 billion company now or whatever. And their poor logo is just like this tiny little thing throughout this whole slide deck. But some of these just like they popped up and they disappeared, which was pretty amazing. But yeah, you were saying Rain Tank.
Rain Tank,
Anyone have heard of Rain Tank?
Yeah. But yeah, I was gonna say, it doesn't count if you work there.
Yeah, that's true.
Right. So yeah, I don't know if they'll give me credit for it. I was the one that like really pushed them to change their name because it's terrible. Like,
are you gonna take credit for
yes, I am actually. Ask Torkel. Ask Torkel.
All right.
I'm sure he's got some logs for that.
Well, the one thing I actually will say about Rain Tank in general in this conference, 2014, Torkel was on stage because it used to be 2 days of talks and a third day was workshops. And he got up on stage and showed the first version of Grafana. And we were all just like, we had all used like Graphite's web UI, which was a special sort of terribleness. And he showed us.
I'm right here.
Sorry, man. Sorry. He showed us Grafana. The whole crowd was like stunned to see something like this that we could immediately use right here. And I remember him being on stage just saying, I would really like to work on this full time if there's any. If anyone would give me money for this, and all the VCs I think were just like salivating because like all the operators were like, give him money, and it turns out they did give him money, and so did a bunch of other people. So
I gotta say props to Centrion. Like you have the same logo for the last 7 years, and it's actually a good looking logo. So yeah, good job on that one. Vivid Cortex, Baron. Yeah.
All right.
Good ones. All right. 2016. What do we have?
Still Rain Tank.
LogZ.
Now we're gonna notice Librato still holding out strong with their logo, but part of now SolarWinds, which will slowly gobble up that logo.
So I'm going to call out BMC. I'm going to assume that was an acquisition, but it wasn't quite yet a trend to say so-and-so buy so-and-so. Like, there's like, I think half the logos on our signs this year are acquisition companies. But.
Yeah, it's usually like the subscript will be, the thing you've heard of, and then the thing that they're like, don't look too closely at who actually owns us.
And I have to pour one out for Packet. Like, I know Packet still exists technically as part of Equinix, bare metal. Love Packet. I was a very happy customer there.
But a couple on here that honestly I have no memory of. Ops Clarity. Anyone remember Ops Clarity? Couldn't really find much on them.
Operable. Anybody else know what Operable was?
If you came to this Monitorama, you have their socks.
I have their socks.
Yeah.
Exactly.
So that was Mark Imbriaco's startup. If everybody remembers Mark, Mark's awesome. He works over at Epic right now. And it was a chat bot something.
Chat Ops
company, yeah. Love their logo, great logo. Yes, the first signing of Sumo Logic. Where's Sumo Logic in relation to Sensu on this one? Is there a
They're
Sensu?
gonna get closer.
Yeah.
Where's
Is there a Sensu? I don't see Sensu on this one.
Caleb, you didn't sponsor this one?
They were probably, no, I don't think they were speaker dinner sponsors at that point. But,
interesting.
I
Alright,
didn't
well.
even notice obscurity until now.
And is Splunk's down there as well. Don't worry, Splunk has got their eye on a few of these companies as well. Don't sell them so short.
All
right, so SolarWinds is like, bye Librado. It was nice seeing you. It's just SolarWinds Cloud now.
Oh, wow, something else happened in 2017.
Oh, yes. Okay, who was here in 2017? It was briefly mentioned in the chat.
And who was over there in 2017?
And
about
also in
half
a
a mile
completely
up.
different location.
So yeah, if you missed that, you probably heard us talking about this week. We actually had an underground fire in 2017. It's actually fairly atypical to have super hot weather in Portland. And if you thought the last couple days were hot, back then I think we were hitting close to 100.
I think it was well over 100, yeah.
Yeah, and they actually had an underground fire in one of the electrical banks or vaults down underground, and we actually failed over to a completely different venue overnight, so that was wild. Let's see what else.
So we got Wavefront, I think they were a new sponsor this year.
Catchpoint, Influx.
Stackstorm as well.
Extra Hot Networks, interesting.
Yeah. Signal
Sciences, Stackstorm.
I would say probably 50% of this slide. This is where really consolidation starts, is 50% of this slide is now part of the other 50% of this slide.
The new Moogsoft logo.
Yeah, where's Moogsoft?
Top middle.
Oh yeah, there you go.
Yeah. Sysdig. Yeah. Pre-blue Sysdig. Yeah.
Pre-blue.
What was Select Star? I honestly have no idea what that was.
Probably a SQL company.
Yeah.
Oh, if it wasn't, then that is such a like.
Grafana Labs. Yeah.
Oh yeah, Grafana Labs now.
Dexta. All right. All right, here we go. Wavefront by VMware.
We also have CA on here, which I'm pretty sure was an acquisition. Humio comes out as a new one. You already said Wavefront, right?
Yeah.
Google Cloud now. This is obviously post-stack driver. It's just Google Cloud now.
Yeah. CA, I think they had acquired somebody, Braintree.
And then this might be the first Gremlin slide.
Yeah.
You'll have to keep me honest. It's also Sensu does their rebrand with the new logo, but in the non-green. That will come later.
So Gremlin still has the Gremlin as their mascot, but it's not part of the logo mark. Is that accurate?
Any Gremlin folks? I feel like the Gremlin's still around. Hasn't gone away.
I think it's probably it's probably an asset, but I don't think they use it in their main logo mark. Lightstep. Lightstep changed their logo after the acquisition. Yeah, that's cool. Op5. I don't know what Op5 is.
Yeah.
Amsterdam. Yeah, familiar with StackPath. Okay, I gotta call it that. Now, I'm probably about to get in trouble, but sorry. Blemio? Really?
Yeah, I'll be really honest. I actually didn't know that was a B.
What did you call it, a fart?
It looked like the fart emoji, right? I don't know if that's actually what you call that emoji, but that's what I call it. I think we actually Google it. It might still be their logo.
No, it is. It is.
I apologize if anyone here works there. But, do what Moog did. Update your logo.
Change your name. Get acquired.
I think the other one too, Isinga. I don't think I ever really computed that Isinga was its own company.
Yeah.
Isinga being the commercial side of Nagios, right?
I guess it's open core, close to it.
Open core before
Signal
Open Core was a
effects.
thing.
Yes.
Signal effects, yeah. Still their own thing.
And then 2019, yeah.
So now you can see Sensu. They didn't like that blue. They went green.
All right, now, who likes the Sensu logo? All right. Do you know I was actually responsible for the Sensu logo? No, I
Is
was.
anyone keeping
I was,
score of
No.
Jason's impact on? Is it just 2 so far? Okay.
That's
There's
what
still time. We have more slides.
That's what I do. I don't want to work for VC. I just want to go out and get employed for a brief amount of time and change their logos.
That's what you want to do, or that's what you have done?
Yes. Yes. I like that logo a lot.
AppDynamics. I don't know if Cisco's on here yet, but they will be soon enough.
1,000 Eyes. I think that's the only time 1,000 Eyes has been here. Wow. Gremlin is really large there.
Yeah. Wow.
Oh, Flowmill.
That's when Gremlin got rid of the thing because it just makes it a
Wait,
little bit
so
bigger.
they don't have two. We don't have two splunks. We just have the one splunk. Flow mill here.
And can we again call out Datadog's logo being just this tiny little, just hanging out. They know who they are. They don't need anything more.
Nice. Oh, Baltimore. Yeah. Light Step, Honeycomb. Wait, was Honeycomb?
No.
The first Honeycomb?
Honeycomb, first sponsor, returning sponsor now
Yeah.
for this one.
Yeah.
First sponsor there.
Log DNA.
These shoes are, so you might have seen some folks wearing,
The blue ones, yeah,
They're
like
the
teal,
blue shoes. That was the 2017 kind of speaker GIF.
Yeah.
These shoes were actually the 2019 Baltimore ones that I had to wear in honor.
So, funny story about those speaker sneakers. That's what we officially call them, speaker sneakers.
That's what you call them.
Is Scott Nasello in the audience today? Okay. So, back then, you could actually order custom sneakers from Nike with a fair amount of customization. I think you could do 7 unique characters on the side of each shoe, and then you could do a custom one on the heel vertically. You could do a custom one on the tongue. You could do all that, and so I did. And we did like it was a speaker on each side. 2017.
Yeah, it was like PDX 2017.
Yeah.
It was like every
Yeah.
side of the shoe had unique Monitorama brand.
They're actually very dope shoes. They're actually very nice.
You are too old to use that word. Don't worry, I am too.
This is for my kids. Poggers. Okay. So, no,
I don't even know what that means. You hear that on TikTok?
You need to get on the Discords. Okay. No, funny story though. We ordered like, I don't know, 30, 35 pairs of shoes, and okay, long story short, I broke Nike's manufacturing system. Literally, as we had some speakers roll over, turn over, and we had to order new shoes, all of a sudden you would see the number of characters they offered for customization go down. Like, this happened 3 or 4 times, and I finally got in touch with somebody at Nike, and I'm like, this is what's going on. Are we breaking your shit? And they're like, yeah, you're actually breaking our shit.
Please, for the first time they've ever said, stop buying these shoes. They do not exist anymore. These shoes are actually customized. The only bit of customization it's impossible to see, it says BAL 19 on the tongue. That is it. That is all they will let you do. And I don't even know if they do any more of these anymore.
Yeah, they're fairly limited.
But this was it, right? This was the last event before this one.
Now, I am very grateful to all of our sponsors. Honestly, we wouldn't be able to do this without all y'all. But it is, I will tell you, it is wild the amount of pent-up marketing demand that I've seen over the past 3 years, for obvious reasons. I'm very grateful that all these companies have been able to help us out with the event. And I'm really grateful that they've hired professional designers as part of their permanent staff, because these are some really good. Honestly, I legitimately like the new Relic logo. I think the old one was fine. I really like the new one. I think the fire hydrant one is solid.
The Datadog designers started to figure it out, that when they put the dog above the words, it was a smaller logo. And if you just keep the dog, right? The dog's never going away. Move to the side, you get a much bigger
They
square footage.
optimized their logo orientation specifically for this event, Pete. I'm sure that's exactly what they were thinking.
I'm gonna Datadog people, confirm that for me. I want to be right once.
I do like the consistency. I like the balance. I will ask, maybe we can kind of try something different other than just logo and word, or vice versa.
What do you want?
Yeah, I know.
Word then logo?
Yeah.
We got some of those. Got some soon.
Well, we do have a lot of acquisition kind of tokens.
Yeah, I think you'll start to notice too is that, like, Sensu by Sumo Logic, you've got AppDynamics post Cisco,
CrowdStrike.
SignalFX. Sorry, Splunk, but you just I don't know, put a gun to them. You were just like, no, it's not like SignalFX part of Splunk. It's like, no, you just Splunk now. Like,
that's awesome. All right, I think that's it.
How did we fill 30 minutes with this ridiculous talk? I have no idea. But
we have 10 seconds for Q&A.
Do you like the framework laptop?
And that's the question we get. All right, that's got to be a hallway track.
Come on, he asked a valid question. I do very much. In fact, they've come out with a newer version. This is the original 11th gen Intel. They've come out with the new 12, and you can actually, it's the same, form factor. As soon as they fulfill their initial rush, I'm going to upgrade mine to the 12th main board, the module. You can swap out all the cards on the side. I could, this thing is literally magnetic. You can peel it off, the bezel.
He has pulled the bezel off of this laptop 6 times this conference, and it's not even over yet.
It's so dope. I mean, look at these. Look at the keyboard. It's transparent. I mean, come on. What's that?
He paid extra for less information. Another question.
You just. What's that?
Have you found the F11 key?
No.
No. Or it doesn't do what it's supposed to do.
What would you need an F11 key for? It's fine.
You have to buy the updated F11 key module to get it to full screen your application. Are there any other questions, or you do also want this unholy talk to just end? Anything else? Someone, for the love of God, if you know what Grok does, it's not the Grok that exists right now. It's some other phantom Grok company. I can't find their website anywhere. I would love to know. What's that?
I just put the link in the Slack.
Awesome. Oh, thank you. Oh, well, also it makes me feel bad. How did you find it so fast? I looked for hours.
And I looked at Monitorama, and then from there was a link from the Monitorama site in 2014.
Oh, how did we not do the original Monitorama logo? Hold on. Sorry. Hold on. We got it. Oh my. How did we miss that?
Well, it started when you screenshotted all the logos and put them on the thing.
All right, hold on. Where's this?
Wow, that's actually impressive. All right, well, we're going to go on an adventure right now.
No, it's fun.
Yeah, no, it's good. Yeah. It's like, I just went to the website and clicked the icon. All right, scroll to the bottom.
Yeah.
Okay, direct you, yes. Nope, not 13, was it?
Yes.
14. Yeah, can we actually talk about visual designer? The OG Monitorama logo, like Futurama?
Yeah, yes, like thank you. Like it is like Monitorama.
Scroll down.
Wait, what am I missing?
Yeah, it's not gonna be this one.
What are we looking for?
No, you gotta go to 14, wasn't it?
Wait, what's 14?
The year that Grok sponsored and then disappeared.
Oh, I just thought you wanted to look at the old Monitorama logo.
No.
Because it's so cool.
He clicked the link to go to the site and it goes somewhere.
All right, so what are we looking for, Grok?
Oh, and it'll probably say what the company does as well.
Oh yeah, I guess.
Jesus!
Yeah. Oh, it actually links to it too.
This is not making us look good at all.
Yeah.
Grok Solutions. I don't know who owns this one, but you can have some fun with that. All right, that's great. Well, that's good to know, and we should next time just read the website.
All right, end of day 2. How was it? I should have asked you before that last talk, but that's all right. Chase that feeling. Awesome. All right. Well, we have some sponsor parties tonight. I don't have them all off the top of my head, but if you check out Tuesday Night Lights, there's a bunch of them. I think somebody was kind enough to do a map. I don't know that all of them are on there, so if you're not, I guess now's the time to spam the Sponsor Talk channel or the Tuesday Night Lights channel. Anyways, thank you very much. I had a fantastic day. I hope you did too. Tomorrow's weather is supposed to be very similar to ours, or to today's, so yeah. See you bright and early tomorrow morning. Get some coffee. Anyways, have a fun night, and we'll see you then.